Hi, good morning, and welcome to Microsoft Virtual Academy. Today we're going to be talking about how to leverage the power of the cloud with your on-prem SQL instances. My name is George, and I'm a program manager from Microsoft. I work on the SQL Server team, and I've worked extensively with the in-memory OLTP feature in SQL Server 2014. And today we have Xin with us.
So thanks, George. My name is Shin, and I'm also a program manager on the SQL Server team at Microsoft. And my focus has been also on the hybrid features in the cloud.
Okay, so today for this 45 minutes, I suppose, we are going to be talking about backup to URL in SQL 2012 and 2014. We're going to be talking about the backup to Windows Azure tool that we have, and we're going to talk about the new feature, manage backup to Windows Azure. And today we're targeting DBAs, IT professionals, and developers, DevOps, people who are people who are already using Windows Azure virtual machines. And we invite you to join the MVA community, and you can get some cool stuff. So first, I'm aware that we already have the backup to URL feature in SQL 2012. So, Xin, can you give us like an overview of what we have in SQL 2012 and 14?
Let's get started.
All right.
So, backup to URL feature is first introduced in SQL 2012 CU2. So, we first introduced the T-SQL statement where we actually now starting support to be on the device type now can actually support URL in addition to the ones that you are familiar with, like the disk and also tape. So first of all, as you can see, the URL type is included in here. In addition to that, we have also introduced the support on PowerShell as well as SMO, like in here. So a lot of the people were asking, why this is useful. So mainly we see the benefits as we can leverage the Windows Azure storage now to be your bottomless feature, so your bottomless storage, so you'll be able to actually do your backup to cloud without have to be concerned about how much storage you have and how to actually manage your devices. And also you get the geo redundancy by default because this is already supported and also provided by the Windows Azure storage.
All right, sweet. So this is really, really cool because right now I can have, a limited kind of storage. But I'm just wondering, what kind of, performance benefits or, even hits that I can expect when I use Windows Azure? What kind of factors will, kind of slow down or speed up my backup?
That's a fair question. So before we go there, and first of all, I want to introduce also, what would be the usefulness of it. Like, when we're thinking about backup to cloud, we want to compare against, first of all, backup to the local box and also even backup to Windows Azure virtual machines. They all have limits, and size is one concern. Right. The size now, we can actually lift that band by using the backup to cloud. On the flip side, there are also caveats or limitations to this feature, of course. As you mentioned, the performance is one part, like what I'm showing up in here is the particular test that we have done. Depending on the network characteristics of your network, right. This is mainly what you're going to see, depending on the size of the backups that you're doing, and also on the other side, the restore, that the size is also based on your network latency as well as the bandwidth. So for Windows Azure virtual machines, we typically have fairly large bandwidth. That's not a big concern. But if your own network has a lot of, it's a low or long latency network, then that could be a bottleneck. So this is going to be proportional to that. On the other hand, you also may have concerns or over, like security or even compliance reasons where you may have, you do not want to consider to even put your backups offside, which is totally understandable. And also that could be a limitation to you. And of course, if your backup file exceed 1 terabyte in a single file, then this would not be for you because that is a current limitation for Windows Azure Storage, blob size as well.
Yeah.
So that is mainly this feature. And we want to do a quick demo just so that people understand what this looks like. So what I'm going to show in here, as I mentioned, we have SMO, we have PowerShell, we have also the T-SQL statement support. And in SQL 2014, we actually did something even you're very familiar with, like the backup restore UI that you already know. This is something that you can actually easily get started using this feature. For example, I have a database in here called TestDB, and I can just pull up my tasks where I have my backup task, and I can just quickly pull up this UI and show you how it's done. So you can see in here, now I have a backup to device type called URL. And for example, if we want to do backup, we could do full or differential or tlog, and let's do a tlog in here. And I can even provide the SQL credential. This is the part where you would need to actually kind of, this is considered as a wrapper for your storage account and also the key. For instance, I have in here, this is the one I have created. And then if you don't have a storage account or a credential, you can actually create it on the spot. And this is the new UI that allows you to do that. So since we already have one, we can just quickly go over and do this. But I want to actually also highlight that we have now also encryption supported within this feature as well, actually across the board. So this is nice to have as well. So for instance, I can specify a certificate, and then I can go back to my general, and then I can do a quick tlog backup. Oops, looks like, I have just given the wrong credential for some. Oh, this is because I'm actually giving this the wrong container. So that's deselect this one, and then go back to that, and see if we have a duplicate of some sort. And let's see. Okay, now my TestDB has just has been done successfully. Going back, we can also do restore, and I would not complete the restore steps, but just want to quickly show you what it's going to be like. Similarly, we'll be actually going through the storage account and provide the key, and that's connect through that. And then we can see that related to my TestDB, we already have this created, and then we can just go from there. So that's basically it.
All right.
So this feature, as I mentioned, it's only for SQL 2012 and above. But what would be the options if we want to actually go back to earlier versions? So this is the part I want to actually hand over to George, so he can tell us a bit more.
So we haven't forgotten about all of you who are still using SQL 2008, 2008 R2, and for those of you who want encryption for SQL 2012. So what we've done is we have released a tool called creatively Microsoft Backup to Windows Azure tool. So what is it? What is this tool? This tool is a standalone installation that adds backup to Windows Azure capabilities, encryption and compression to prior versions of SQL Server. So it doesn't matter if you're using SQL 2005, 2008, or 2008 R2, or 2012. You can use this tool to back up to the cloud almost from any version, as long as you have a Windows Azure storage account. So also, this tool adds backup encryption to these versions as well. So this tool can encrypt and compress your backups as you need it and if you want it. And this tool is easy, very easy to configure. You can install it in 5 minutes, and you can configure it in another 5 minutes. Last but not least, for those of you who do not have a Windows Azure account, or for some reason do not want to use the cloud storage, you can use this tool to encrypt and compress your backup locally. So you can use it to add that feature to your SQL Server instances as well.
Yep. I think, a lot of times we heard, our customers asking for backup encryption for a long, long time. So
Yep.
this would be their route to actually now get it all supported for even earlier
Definitely.
versions, which is really cool.
Definitely. So let me show you actually how it works. Here I have a, well, Windows Azure VM instance. You can use this on your on-premise as well. And I have a single database over here. So the tool is actually, the configuration is actually this window over here. So you can see we have rules that dictates what the tool actually looks for in a file system. For example, this one here looks for files, with the .bak extension in the F local backups path. So whenever SQL Server backs up to this path, the tool will look for the I/O operations actually into this file by SQL Server. Now, in this step, we can choose to use local storage, in which case these fields won't apply, or we can choose to use Windows Azure storage, in which case you will have to provide the storage account, access key, and container. So let's use local storage. And now in here, you can see you can provide encryption. We're using AES-256. Provide a password of your own, and you can enable compression or disable compression as you want. So let's finish. So under the local backup, I have already created a backup, and you can see you have two files here. One is the actual backup, the backup stub file that we have. The other one is the encrypted backup file. So let's do an Azure backup. So here I have a rule that dictates that that the tool will stream the backup to the cloud, and I have provided my account key. Now let's do a backup. Task, backup. As you can see, the interface here doesn't change at all. SQL Server is not aware of what's going on in the background done by this service. So what I'm going to do is I'm going to choose a backup location that is the Azure backup folder, and provide a file name. And now click OK. So the backup is done. And let's go to the folder. Remember, we are seeing two backup files over here. But let's see, we only see one here. This is the stub file that we have. And let's go to the container. And now you can see the backup files over here on my storage account.
Cool.
Restoring a database works relatively the same way. So let's choose the backup file that we done. Backup. So let's restore it to something else. And click OK. And you see the restoration is finished as normal. So you can use this because SQL Server isn't aware of what's going on in the background by the service. You can use it with any instance that you have, 2008, 2008 R2, and 2014 even. So let's go back. So this is pretty cool. We haven't forgotten about our loyal users from before,
Yep.
who uses our older instances. So we have also added a really cool feature in SQL 14, which is managed backup. So Xin, can you talk a little about that?
Sure. So Managed backup is really to take a step further compared to the backup to cloud feature that we have just introduced. So the backup to cloud feature, like, whether you're doing that through the UI, you're doing that through T-SQL SMO, or even the tool, a lot of times you're thinking this still as a menu option. Even for maintenance plan, for example, when you're thinking about it, you actually just, deciding on whether, how frequent that is going to be done, but the underlying backups doesn't really have that much intelligence. So that's the whole reason that we're introducing this new feature called Managed Backup. We're actually taking care of your backups, not just the backup itself, but also the policy of managing those backups. So the origination of this idea is that we want to provide, especially for customers who are already using the Windows Azure virtual machines, running their SQL servers in those virtual machines, to actually take full advantage of this storage, so that they think of this, they inherit all the benefits that the storage provides, like the bottomless storage, and also you don't have to manage all the devices. You have zero hardware management requirements. And also, on top of that, our algorithm provides a lot of intelligence, which we'll talk a little bit more later. And what you want to think about this, that this is a feature that involves very little exposure of the knobs for you to really kind of meddling around, because the idea is really to free up your mind, to actually leave you to focus on something more important, like your app development. So this is why we have our ideal candidates is really like small, medium business, who actually the customers may not be that seasoned with DBA type of jobs, and they want to actually this to be taken care of. What they want to focus on is to get a guarantee of their recoverability, which is exactly what we're providing in here.
Okay, sweet. So, I mean, database backups are usually, my last line of defense against, data corruption, data loss, failures. I mean, usually I would want to be involved in this process as much as possible, So, why do I want to hand it off to, to the computer to do it for me instead of,
That's a fair question, because a lot of customers, we know that this may not be for everybody. So that is why we want to make sure when we're thinking about it, it is the guarantee of the recoverability that we're providing, as well as, you can take full advantage of the cost of the storage, lowering your cost, and also depending on, your comfort level, whether you want this to be taken care of. This is a trade-off between your, you want to focus on your business logic, and also you want to free up your cycles to make sure, especially for some of the archiving options, we see this as a great opportunity. So this is why, when we're really summing it up, it comes down to two aspects. One is that, you can actually do a bit larger scale management now. Thinking of this feature, you can not only take advantage on the database level, per database, but also you can actually do it on the entire SQL instances. So for instance, if you have thousands of SQL databases on a SQL Server instance, this would be really ideal, so that you have this kind of out-of-the-box default value turned on, applied to all these databases, and then you don't have to worry about a thing. And then all of these are going to be uploaded to Windows Azure Storage account and maintained, or retained those for a period of time that you specify. And that is going to be actually adding a lot more value as we see it. So that's probably going to be jumping right into the business, how we actually think about the intelligence. So the intelligence, there are actually quite a few aspects of it, but I want to just highlight two aspects in here. One is what we call as a main loop. This is like the brain of this algorithm, to think about how we actually deciding on whether or how frequent we want to take a backup. So whether it comes down to a full backup or a log backup, we have certain thresholds that we consider. So it's not just dumbly like a maintenance plan that takes a backup at certain interval, but it also considers the activity of your system that is live. So it actually see whether it needs to fall back or it actually needs to be more aggressive. For instance, if we're thinking about the full backup on a regular database, we actually take about a full backup every week as a bare minimum. And also log backup, it takes, the loop actually runs every 15 minutes. We loop and go through each and individual database to see whether there is a need to take a log backup in that case. Based on what? Based on the log accumulation, to see whether there has been enough change. For instance, if there has never been a change applied to this database for the last 15 minutes, why take a backup? There is no reason that you don't have data loss in that particular case, right? So we don't have to actually just do that, kind of on the drum. And that's why, this offers a lot of, opportunity actually to optimize. And on the other hand, we also want to highlight, there is the retention. Retention actually is not just, based on the timestamp that we keep your file up to the Windows Azure Storage account for that duration, but more, we actually look at the dependencies between your backup files and determine which files need to be kept, just so that we can guarantee your recoverability up to that days. So for instance, if you have a 14 days of retention, even if you drop your database on that spot, we'll still keep those files just so to make sure that you are able to recover. So this is going to be, a lot more intricate than those actually we see, based on timestamps. So this is something, we want to also, highlight as well.
Excellent. This looks really, really cool. But I just want to, I'm a visual learner. I want to see it in action. So
Sure.
Can you show us
Yeah,
how it works?
that brings us to our demo. So I have a virtual machine in here, which is already in Windows Azure, but it doesn't have to be. So it can be any machine that you have probably on premise. So for instance, in here, if you remember, we actually have in the menu backup option, we need to have a container, right? But for Windows, for our managed backup, we actually take care of even the creation of the containers and also, of course, the file naming of your backup files. So for instance, in here I have this SQL Server instance, and based on that, I already have a container created. So you can see that in here, wow, I already have a number of backups already taken. Why? This is because I actually just previously set up the feature. So if you remember, for the backup to cloud option, we need a credential. And similarly in here, this is also a prerequisite for you to be able to have a credential so that you can communicate. You have a way to actually upload your backup files to the Windows Azure Storage account. Once you have done that prep step, you can just use this main SQL statements. This is the stored procedure you would want to use to enable the managed backup, or what we call it, smart backup, because we think it's pretty intelligent. And in here I have, for example, in here I have this at the instance level, meaning that all the new databases that I'm going to be creating at this point and on, I would actually use this, this would be actually applied to all these databases. So they come out of the box, have already this, being covered. You also may notice that, I have encryption in here as well. And this is also based on the certificate that you would need to create beforehand. Of course, this is an option, so you don't have to use that. And of course, in addition to the instance level, you also have the option to actually see, I can actually enable this on the database level, or you can override that, the database, the instance default by this particular value. So for instance, I can actually do different, either a different storage account, or actually I can even do a different retention period, whichever you would like. So this has already been applied. And secretly, I've also actually have a little bit seasoning going on, actually, because we want to see things in action, right? And I just mentioned that we actually have this, the algorithm takes care of the backups every 15 minutes. This is the loop through that it's done. But, right now I want to show things in action, so we don't want people to sit and wait and see how those backups are going to be popping up. So that's why I actually reduce the frequency. So that's actually going to be much more aggressive. So it's going to be actually looking through all the backups or the databases actually every 15 seconds. This is, of course, it's not going to be the case, when you are seeing in production. This is just something I internally set up because of the demo purposes.
Okay.
So let's see why that is going to be important. So before that, let's first check off to see if we actually see the results in here. Yeah, we can confirm now that the managed backup is actually enabled, and also the retention is set to be 30 days. This is at instance wide, and the storage URL it goes to is just corresponding to my storage account I just mentioned, so which is exactly the same in here. And now I'm actually going to be doing something a little bit more interesting. What I want to do is that, as we can see in here, we have a number of databases. We have WPC and TestDB, a number of them. But they have been sitting in here for a little while, and with the fixed number of database backups, there is no more activity that's being generated. They're just sitting down there. But for this particular database called Fabricam Managed, I want to actually trigger some activity so that we can see whether this is going to make some difference and how the managed backup is going to handle that. So what I'm doing right now is to actually generate a fake load. So it keeps running, and we can then compare and see the differences in terms of the backups that's going to be showing up in this container.
All right.
So let's give it a couple, maybe 30 seconds or more for it to finish, and then we can actually refresh this container and see if the number of backups showing up in here would be any different. And of course, for the rest of the databases, it's not going to be impacting, so we don't expect those to actually change.
Okay, so.
Okay, looks like it just have finished. And then if you remember, we have just seen, I think, a new log backup to pop up. So this is, why we claim this is the, intelligence of the algorithm, not just only to actually manage the instance, the creation of the containers, the retention, but also it takes into the activity of your databases to actually, even do throttling if there are a lot more activity going on. So even user action detection. For instance, if your customer do actually delete some of the files, we also try to mitigate that by taking a more immediate, full backup in that case, so that you don't actually have, extended exposure over time, on your recoverability.
Cool.
So that's that.
So it looks pretty smart to me. So my understanding is that this is a new feature in SQL 2014. I mean, this is a V1 product, and usually with V1 we have some kind of limitations.
Absolutely.
And,
yep.
Kind of
You're spot on.
Yeah. So,
yeah. Actually, this is the list of our limitations for V1. We actually think, of course, there is a boundary for us to, do the scoping. So that's why, a couple of things here I want to mention. First of all, the destination for all your backups for managed backup is only right now supporting the Windows Azure storage. So we cannot, for now, for instance, do Amazon or any other, kind of storage, cloud storage type. And also the backup types. As you can see, the difference between the menu option is that the menu route allows you to do differential backup, but for managed backup for now, we can only do full backup and also T-log backups. This is also a scoping decision. We have to cut somewhere. And also the databases, we only do support user databases. So for system databases, it's not supported for now. For recovery mode, it's right now only support either you do full or bulk load mode, and we don't support like simple recovery mode. And something like you would actually expect is that it is inherently it would actually be in conflict with some of the other backups in parallel. If you're setting them up side by side, it is very easy to confuse the algorithm, because we will actually recognize that as a broken chain, because the LSN will no longer be consecutive if it's taken also in parallel by another manual backup or maintenance plan, and then in that case we would actually be triggering more backups to compensate. So that is the case where we see conflict. That's why you would only want to enable one at at one time. So those are some of the V1 limitations that we'll be considering and also addressing, and some of them currently are really just by design.
Okay, all right. So that means that I can't actually, I wouldn't want to take a manual backup if I enabled manage backup.
You would want to, the option is still there. You can actually do a copy-only backup, for
Right.
example, if you want to do the manual route. And then, in that case, it wouldn't impact the backup chain recognized by the managed backup. In that case, we're still intact, and then we can continue, guaranteeing your recoverability.
All right, sweet. Okay, so today we've talked about, in summary, today we talked about how we can back up to URL, how we can use T-SQL, use PowerShell, use Small, and we can use UI to back up to a Windows Azure account. We talked about the backup to Azure tool that applies to both the current version, SQL 14, SQL 12, and the previous version, SQL 2008 and SQL 2008 R2. And today we talked about the managed backup to Windows Azure, which is a really, really cool feature that can help you maintain your databases and take the load off of you, and just gives you the cycles to actually do things that help your business more than ensuring that the backup is there. So we're going to take a 15-minute break. Don't go away. We'll be right back.
Welcome back, everyone. My name is Darmadi Como. I'm a host for this session. With me, I have Luis Carlos from engineering team. Hey, Luis, why don't you tell us who you are and then what you're going to talk about today?
Sure, absolutely. Hi, everybody. My name is Luis Vargas. I'm a program manager on the SQL Server High Availability team. So today, we'll be talking about SQL Server High Availability and Disaster Recovery on Windows Azure virtual machines. So I'm really excited to talk about this. We have this new offering for running SQL Server in the cloud in Windows Azure. And we're going to be talking about how can you ensure high availability for your SQL Server running in a virtual machine in the cloud, as well as how can you achieve disaster recovery for your on-premise SQL Server databases using the cloud as well.
Okay, great. Why don't you show us what is Windows Azure VM?
Sure. So let's start with an overview first of what Windows Azure VMs are, and then we'll go into SQL Server running on Windows Azure.
Okay.
So first, Windows Azure VMs, basically what this means is you can have virtual machines hosted in Windows Azure, what we call infrastructure as a service. And this basically means that there is a host machine that is hosting virtual machines for you. You can have these virtual machines. You can create, you bring your own images. So you can prepare, for example, VHDs on-premise and then upload them to the cloud and provision virtual machines out of those images. Or you can create virtual machines from the images that Microsoft provides. And we have many images for the different products that we have in Microsoft. And one of those products is SQL Server. Provisioning a virtual machine is really fast. So in less than 10 minutes, you can have a virtual machine running SQL Server in the cloud. You only pay for what you use. So this is a fantastic offering. So you only pay for every minute that you use that virtual machine. You don't pay for more than that. How much you pay will depend on the size of the virtual machine. We have many different sizes with different numbers of cores, different amounts of memory. And based on that is how the price is determined. And also there is some cost associated with the licensing. So if you're running SQL Server, for example, there is some licensing cost associated with that.
But I save money on my hardware. I don't need to worry about hardware upgrade and maintaining the hardware and all that.
Absolutely, yes. So you don't have to think about buying all that expensive hardware. The moment that you need it, you just provision the virtual machine, and then you have SQL Server running there.
Okay, awesome.
In terms of the network, you only pay for outgoing traffic, not incoming. So actually, it seems there is a hint there in the deck. You only pay for the storage that you use. So even if you allocate multiple terabytes of space, for example, for your virtual machine, you only pay for the space that you actually use in those machines. It's an elastic offering. What this means is that at some point you may start, for example, with a small virtual machine, and you may have only 1 core, for example, and 2 GB of RAM. But you can go and increase this into 8 cores, for example, and 56 GB of RAM. Same thing on the storage. You can start, for example, with less than 1 terabyte, and you can go all the way to 16 terabytes of data.
Wow.
So it's a really elastic offering, and you can just do this by changing a couple of properties in the Windows Azure portal. And we will actually show some of that in the demo.
Okay, great.
Finally, this is still an infrastructure as a service offering. And what this means is you are in charge of the virtual machine itself. So if you need to do patching, for example, of that virtual machine, or SQL Server inside of the virtual machine, that's something that you still need to manage.
So I still have full control of the
You have full
virtual
control of the virtual machine,
Right,
right?
okay.
It's just another machine, but it's running in the cloud.
Okay.
In terms of storage, every disk that you attach to that virtual machine where you can store your data is storing what we call Azure storage, which is basically a centralized system which is highly available, highly secure. And the way this works is for every disk that you have, we have 3 copies running in Windows Azure storage so that we can ensure that you never lose your data. So even if one of the copies goes down or 2 of the copies goes down, you still have an additional copy. It's highly transparent, so let's say that one of the disks goes down for some reason, we'll automatically switch to another disk under the covers, and this will be transparent to the virtual machine. And this is what this is illustrated in the picture that we're seeing here. So you have 3 copies of your disk running in Windows Azure storage. In addition, we have 3 more asynchronous copies in a different data center. And this is so that in case that one of the data centers goes down, for example, you have a different copy in a different data center where you can continue running as well.
Okay.
So highly available and support disaster recovery as well. In terms of high availability, I want to introduce first what the platform offers in terms of high availability for your virtual machines,
Okay.
and then we can drill down into SQL Server high availability. So just from the platform perspective, the way it works is you have different racks, right? And each of these racks has multiple physical hosts, and then these hosts have virtual machines. And then the way it works is you can put your virtual machines in what is called an availability set. An availability set is a concept from Windows Azure, and what that ensures is that all the virtual machines that you put there end up in different racks.
Okay.
Right? So that in case that one rack becomes unavailable for some reason, because there is a cable, for example, that fails, you still have a different virtual machine in a different rack that you can access. Right?
So it's no single point of failure.
There is no single point of failure, exactly. Yeah. And then traditionally, what applications do is they have some load balancer, right, between the application and the virtual machines, so that load balancer is routing those requests to both virtual machines. In case that one of the virtual machines goes down for some reason, you still have another virtual machine where you can route all the requests.
Right.
So that's just a general context of how applications in general handle high availability, and it's going to be useful when we talk about SQL Server high availability.
Okay.
So let's start talking about SQL Server on Windows Azure VMs. And let's talk about first about high availability and disaster recovery, because that's what we're going to focus most of the discussion today. So in terms of high availability, the first SLA that we have is you'll never lose any data. So we guarantee you that through the 3 copies of data that you'll always have your data available. If a virtual machine becomes unavailable for some reason, right, and this reason could be, for example, let's say that there is an upgrade that is happening on the host machine, right? At that point, the virtual machine will automatically restart in a different host, right? So there is an SLA from Windows Azure. The SLA is for when you add 1 or more virtual machines in an availability set.
Right.
And the SLA is 99.95 minutes, which means that less than 22 minutes of downtime per month, right? So this means that over 1 month, at most 22 minutes, you won't have any of the VMs accessible, right?
Okay.
And this SLA includes planned downtime due to monthly patching of the host machine, right? So every month we do patching of those host machines, and also includes unplanned downtime due to physical failures. So if for some reason the physical host fails, that is included as part of the SLA, so you don't have to worry about that. This still doesn't include anything that you do inside of the virtual machine. So if you, for example, go and patch the operating system, that won't be included as part of this SLA, and that's something that you need to handle, and we'll talk about how you can do that. In terms of disaster recovery, currently we don't have an SLA, but based on empirical tests that we have run, it's less than 30 minutes of potential data loss between data centers. So let's say that one data center goes down, which so far hasn't happened, and in the worst case scenario, you will have less than 30 minutes of data loss. And the reason is that you have an asynchronous process that is replicating the data between data centers, and we don't do it synchronously because we don't want to impact the performance on the primary data center.
Okay, but it is a full version of SQL Server, meaning that all the features are supported. I can run SQL Server application there as if I run it on-prem.
Exactly, and we have one slide, I think the next slide that we'll talk about that. Something else that I wanted to describe is we have external connectivity to these Windows Azure VMs. So you can connect to these VMs over the internet, right? Just you can create what is called public endpoint, and you can just connect to them over that endpoint. Or you can have a site-to-site tunnel for secure connectivity between your on-premise environment and Windows Azure. So you can create what is called the site-to-site tunnel, and this will basically allow you to extend your on-premise domain into Windows Azure. So by doing this, for example, you have access to all the domain credentials that you have in your premise environment, and you can use those to authenticate into virtual machines in the cloud. Right? So very powerful mechanism. For example, if you want to be able to apply all those policies that you have today on premise, policies, for example, regarding firewalls and things like that, you can just extend your domain into some of those virtual machines in Azure, and those policies will apply there. In addition, you can use your Windows domain credentials, for example, to authenticate to those virtual machines. So people who are using Windows authentication today, for example, for SQL Server, could continue using that into those virtual machines in the cloud without having to change the security settings.
Okay.
This is what we're showing here. So you can have your on-premise environment, right? The way this works is you either configure a VPN device, like your Cisco router, etc., or you can configure Windows Remote Access Services in Windows Server, and you can have a software-based site-to-site tunnel between your on-premise environment and Windows Azure. And on the Windows Azure side, we have a gateway that basically establishes the secure connection.
Right.
So we're talking about SQL Server in Windows Azure VMs. We have many versions of SQL Server supported. So we support since SQL Server 2008 or 2, SQL 2012, and now we even have SQL Server 2014, CTP1, and recently we released CTP2 as well. So you can go and play with that. We have, we're saying almost 100% compatibility. The only thing that we're currently working on is supporting SQL Server failover clusters. Right. Besides that, everything else in the programmability surface is supported.
Okay, like integration services.
Integration services is there.
Reporting services is
Reporting
there.
services, yes.
Okay.
Analysis services, spatial data, whatever you can think of is there.
Okay, awesome.
Right, and as we described before, because you own the virtual machine, you still own SQL Server, right? So you can manage your security, you can manage your backups, and you can even go and manage high availability and disaster recovery. And we'll talk about why would you want to do that.
Now I'm so eager to see what it looks like. Can you show us in the portal?
Yeah, absolutely. So let me show you quickly how this works. So let me check here. All right, so what we have here is the Windows Azure portal, right? So you can see here we have all the different services that we offer in the cloud. All right, so let's see, you can see it here, okay? So we have all the services here that you can offer in the cloud. The first one that we're going to talk about is virtual machines. So if you want to go and provision a new virtual machine, all you have to do is click on New, right? And then you can select Virtual Machine here. And you can specify if you want a quick create from gallery. I'm just going to do it from gallery to show some of the options that we have in the gallery. So here you can see all the different types of images that we support, right? So you can see, for example, that for SQL Server, we have SQL Server 2014, CTP2. We have 2012, SP1 Enterprise. We have images for data warehousing. We have Standard Edition. We have Web Edition, all the way back to 2008 or 2.
Okay.
Right, so you can select one of these. So for now, I'm going to select 2014 CTP2, the latest image that we released a couple of months ago. It gives you some information about SQL Server here. I can give a name to my virtual machine, so I can say my VM, give it some unique number there. I can select the size of the virtual machine, so this can go from extra small, just one core and 768 megabytes of memory, all the way to 8.7, which is the largest VM that we have today with 8 cores and 56. So for now, I'm going to select a large one. I can give a name to my administrator. So I'm going to say Vargas, and I can give it a password. And this is the password I'll use to manage the virtual machine. Oh, matching that one. Okay, let me make sure I have it here. Okay. So after that, I can specify where do I want to create it. So the cloud service is basically a container. So if I have multiple SQL servers, for example, and maybe the mid-tier and some web servers, I can put it in the same cloud service, and it's just a container for my application. Okay. I'm going to tell it to create a new cloud service. I can give it a DNS name, and this is a name that I can use to connect over the internet to that virtual machine if I want to. Okay. Here I can select where do I want to locate this. So I can either say I want it in a specific region. Right? I can put it in North Europe, West US, Central US, all the different data centers that we have around the world. Or I can put it in what is called a virtual network. And this virtual network is basically the side-to-side tunnel that I talked about before. So I have created, for example, 2 virtual networks here, and we'll look at this later in the demo. Okay. But basically, these virtual networks establish connectivity between my on-premise environment and some region in Windows Azure. Okay. So by putting it in one of these, it will go. It'll be accessible to my on-premise domain with all my security credentials there. So let me select this one, for example. Some information about subnets, so people who have different subnets can use that, and also the storage accounts. So I can have different accounts that I can associate with different storage spaces. And what this means is I can manage my storage, right, to different accounts. So some people, for example, may require a lot of storage. I create one storage account and I assign it to them. Okay. Right, so in this case, I can say automatically generate one. We talk about the concept of availability set. So if I want to make sure that these VMs are in different racks, I will put them in the same availability set. In this case, this is only one, so I won't do that. Finally, I can select how do I want to be able to connect to this virtual machine. So I can, for example, enable the remote desktop endpoint. Right? If I want to go and connect to remote desktop, I can enable remote PowerShell if I want to run remote PowerShell commandlets, etc. And then after that, I can go and execute this, and 10 minutes later, I'll have a virtual machine running with SQL Server. So hopefully that gives an idea of how the provisioning process works. Mm-hmm. So let's go back to the presentation.
Yeah, you alluded earlier about having SLA, right, 99 point something, right, in Azure by itself, has 3 copies and everything. But for a lot of our customers, they want actually higher SLA, meaning that they want more high availability.
Right.
Yeah, so I want, if you can describe, how do we do HANDR within Azure VM?
Sure, absolutely. Absolutely. So let's talk about the SQL Server HANDR scenarios in Windows Azure VMs. As you mentioned, well, the platform already provides some high availability and disaster recovery, but on top of that, you can even achieve higher levels if you want to through SQL Server. Right. So let's discuss this. So we have 2 scenarios. The first one is you have your SQL Server running in a Windows Azure VM, and you want to make sure that you have high availability for SQL Server, right? The way this works is exactly the same way it works on-premise, where you can have replicas, right? And those replicas are available for automatic failover, so that if the primary replica goes down, you have another replica that can take over very quickly. So we'll talk about that, and we'll give more details. The second scenario is achieving disaster recovery for your on-premise SQL Server. So that SQL Server that you're running today in your company, you may want to protect it in case that your full data center, for example, becomes unavailable. Right? So you can have a different copy, one or more copies now running in Windows Azure that are available to you, so that in case that your on-premise environment is unavailable, you can fail over to that copy in the cloud and continue running your applications there.
Okay. Got it.
So let's talk about the first scenario, high availability for SQL Server in Windows Azure. So why would you need to do this? Well, the first reason is that the failure detection that Windows Azure does is at the virtual machine level. So there is a heartbeat mechanism going on between the host machine and the virtual machines that it hosts, and it will detect failures in the virtual machine. However, it will not detect failures inside of the virtual machine, because for privacy reasons, that's your virtual machine, and we don't see inside of it. Okay. Right? So you may want to be able to detect failures in SQL Server, for example. You may also be able to quickly have another SQL Server running in case that you want to patch your SQL Server, right? So you have some PCUs and CUs, and if you want to patch SQL Server, that requires some downtime, right? And to avoid that, you may want to continue running in a different SQL Server. And finally, you may want to patch the operating system itself in that virtual machine. Right? So you may want to patch Windows, and as part of that, you may want to, again, fail over to a different SQL Server. The other reason is the process of service healing. Service healing is when Windows Azure detects that for some reason the host machine hosting the virtual machine is unavailable. In that case, Windows Azure will restart that virtual machine in a different host. That process today takes around 12 minutes, right? So for applications that cannot support 12 minutes of downtime, they will need to configure a high availability solution for SQL.
Okay.
Right?
Got it.
And the final thing is every month there is an upgrade process that happens one day, right? Couple of hours, where Windows Azure goes and upgrade all the operating systems for all the host machines, right, in the data center. Now, that means that during some time, that virtual machine is going to be impacted, right? And that's around 15 minutes today. So while the upgrade happens, your virtual machine may be down for 15 minutes. So again, if you don't want to, or your application cannot support that downtime, then you can configure a high availability solution for SQL.
Okay.
So what do you do? Well, what you do is the same way that you do today on premise. You can configure a high availability technology for SQL Server, where in this case we have this in Windows Azure. And you can have 3 virtual machines. You can have your primary, your secondary, and what is called the witness, right? And the witness is basically the additional entity that orchestrates automatic failover, right? So in this case, if, for example, the primary goes down, the secondary will automatically become the new primary. Right? Your applications can continue running there. At some point in time, the previous primary will come online. Right? Now it will come back as a secondary, and it will start resynchronizing transactions again from the primary. Right? And that's how you can achieve high availability continuously in Windows Azure. Now, what this provides is failure detection for SQL Server. So if there is anything impacting SQL Server, for example, a continuous out-of-memory situation, that will be detected by the SQL Server H8 technology, and then the failover will take very little time. It's around 15 seconds.
Okay.
And 15 seconds is a lot better than 15 minutes, for example. So if you want to have that very high level of high availability, you can do this.
Okay.
Right. In terms of technologies, the technologies that we support to do this are the same technologies that people are familiar on-premise today. So you probably have used already availability groups that we released in SQL Server 2012.
Yeah.
You can achieve, obviously, zero data loss. We ensure that if there is an automatic failover, the new primary contains all the data that we have before in the secondary. You can have many databases in the scope of an availability group. So if you have an application that takes a dependency, for example, in 3 databases, you can put those 3 databases in the same availability group, and the availability group will fail over all of those databases together. Okay. You can have many replicas. So in SQL Server 2012, we supported 4 secondaries. In SQL Server 2014, we support 8 secondaries, 9 replicas in total. So you can have all those levels of protection if you want to.
Okay.
Obviously, we support automatic failover, and your secondaries can be readable. And what this means is you can use these secondaries, for example, to offload some of the reporting workloads out of the primary and run them there. Right? We also support database mirroring, right? A solution that we have supported in the past is still supported. The scope is a single database, so if you want to configure high availability for multiple databases, then you configure database mirroring for each of those.
Right.
I wanted to mention availability groups have many advantages. So besides the capabilities that we described before, like readable secondaries, you can have flexible failover policies, where you can specify different conditions that will cause SQL Server to fail over. You have automatic page repair, where we detect that a page is unhealthy, is corrupted, then automatically we request that page from other secondaries, and then we'll replace that page. We support backup on secondaries, so you want to move some of your backups to the secondaries to save I/O resources, for example, you can do that. And support for other features like file stream and file table, etc. Something that is important to remember is with availability groups, you need to install a Windows cluster. Right? Okay. You don't need shared storage. Some people sometimes believe that they need. You don't need it. All you need to have is install Windows cluster between the machines. Right? And these machines need to be part of the same Windows domain. Right? So you need to make sure that if you configure this in the cloud, that you configure an Active Directory domain controller. And we have all the instructions of how to do this.
Okay.
Something that is important for people who go and configure high availability in Windows Azure is you need to make sure that you tell Windows Azure where to allocate these virtual machines, right? It's important because in this case, the environment is a cloud environment, right? And you want to make sure that your virtual machines end in the best possible way, in the best possible place, sorry. So there are three things that you need to think of. One is make sure that these virtual machines are part of the same affinity group. This is a concept from Windows Azure. And basically, this means are part of the same Azure cluster. And a cluster is a set of racks that are close together.
Okay.
And the reason why you want to do this is because you want your primary and your secondary to be close, because you want to reduce latency between them.
I see.
Right? You want to make sure that your secondary is continuously synchronizing as fast as possible. You want to make sure that they are part of the same availability set, as we described before. This basically means they're different racks, right? This also ensures that they are in different upgrade domains. And what this means is that every month, that day when Windows Azure does an upgrade, it will only upgrade one of those virtual machines at a time, right? So you can ensure that at least you have the rest of the other virtual machines running, right? And that's how you can ensure that there is a failover and you can continue running on another virtual machine. And finally, make sure that your virtual machines are part of the same virtual network, right? The virtual network will ensure that the IPs of those virtual machines never change.
I see.
Right? And this is important because in the case that that virtual machine moves to a different host machine, you want it to maintain the same IP, because if not, changing the IP in the DNS may take some time, and that's time that you may not be able to connect to your virtual machine using the name, only the IP. Right? So to avoid that, just use the virtual network, and then your IPs always remain the same. And you can always connect to the name without any delay. This is an example of the type of configurations that you can achieve in Windows Azure. So in the same availability group, you can have multiple replicas. So in this case, for example, we have one primary and one secondary, right? And then you have your OLTP application that is running transactions into a SQL Server. And it is connecting to the primary through something called the listener. And the listener is a DNS name that your application can use to find the primary. Right? So even if there is a failover here to replica S1, your application will be able to connect transparently to that one. And then you can have, you're probably wondering what these readable secondaries are. So you can have multiple readable secondaries, right? And if you have, for example, one or more reporting applications that need to use your data, right? You can move those reporting applications into your readable secondaries, right? And you can do things like configuring and load balancer in Windows Azure. And then you can load balance all those requests for the reporting applications across all the readable secondaries. So very powerful way of how to scale out your application, for example, in the cloud. Right?
This is all great. We can do all this in the cloud.
Yeah.
I'm sure that some of my customers, they're thinking like, I'm not that ready yet to move my primary machine to the cloud yet.
Yeah,
Right? I want to make sure that all my mission critical databases are stay on-prem.
Exactly.
And I want to use Azure just for my disaster recovery scenario.
Exactly.
Is that possible?
Absolutely, absolutely. So actually, let's go and show the portal again. I wanted to show how can you go and configure this tunnel that I mentioned before on-premise on the cloud, so that you can have this secure connectivity between the two. So let's talk about how can you achieve disaster recovery for your on-premise SQL Server in Windows Azure. So, okay, let me talk a little bit about the why, and then we'll look at the tunnel. So why would you want to do this? So the main reason is there are events that you don't foresee, and these events may cause your SQL Server to become unavailable. Some of these may be temporary, and they may be just there may be a gateway failure, for example, that is causing connectivity to fail to that SQL Server, but they may be permanent as well. There may be flooding scenarios, for example. So we saw cases, for example, in New York with Hurricane Sandy, that some of the data centers actually became impacted because of that. And in those cases, people who have disaster recovery sites were able to continue running by doing a failover to a different data center, right? So the problem is a disaster recovery site is expensive. Right? You need to pay for rent for the site, you need to pay for maintenance, you need to buy the hardware, you need to maintain the hardware, you need to pay someone to be able to take care of the site, right? Some operations people. So because of that, we believe there is substantial value in having a solution that is cost-effective for you. And what we're doing now is, since 7 months ago, we started supporting disaster recovery replicas in Windows Azure.
Okay.
And this is what is shown in this picture. So in your on-premise environment, you will have your primary, you will have your secondary for automatic failover. So you still have your high availability managed locally, right? But if you want to have an additional copy, one or more copies outside of your data center, you can go and add these replicas in Windows Azure virtual machines. And now these are SQL Server copies that will be continuously synchronizing all your transactions from on-premise, right? So that at any point you can fail over to those replicas and continue running. So what you can do is you can deploy, as I mentioned, one or more secondary replicas for your on-premise SQL Server. These replicas continually synchronize. So the way this works is every transaction that you execute in SQL Server will create a log record, right? And we automatically send those log records into the secondary in the cloud, right? And that replica in the cloud will have a copy that is up to date with the primary. As I mentioned before, that replica in the cloud is using Windows Azure Storage to store all the data. And as we described, Windows Azure Storage is highly available, has 3 copies, and also has its own disaster recovery solution. So you can guarantee that never you will lose any data that you send into that replica in the cloud.
Okay.
Right? So very powerful mechanism. You can put these replicas in the best region for you. So we have many regions today. We have more coming. So we have West US, for example, East US. We have regions in Asia. We have regions in North Europe and West Europe, etc. Right? As I mentioned, there are new regions coming as we talk. How do you decide where to put it? This will depend on a couple of things. One is latency. Mm-hmm. So you want to make sure that you keep latency relatively small. Within 60, 70 millisecond round trip between your primary data center and the cloud. And also, I know that there are some countries that have some political considerations on where they cannot keep the data, right? Some of those countries can look into some of the regions that we have and decide based on that. Mm-hmm. Very important, very low TCO, total cost of ownership. The only thing that you pay for is the virtual machine and the storage, right? As we described before, all the traffic that you send into the virtual machine is free. Okay. Right? So if you're synchronizing transactions from on-premise to the cloud, this is very important because you don't have to pay for that traffic. Right? Something to mention at this point is I actually have seen some customers where they invert the deployments. So they actually run the primary and the secondary in the cloud. Right? So the application is running in the cloud, but they want to keep a local copy on-premise. Some people like to maintain that copy, for example, for local reporting reasons, or some have actually compliance and policy reasons where they need to maintain a local copy. Like there are some hospitals, for example, that need to have some local copy of the data. So even if they're running some applications in the cloud, they need to maintain that. So that's totally possible, and you can do that as well.
In this scenario, does the traffic that comes from the cloud to on-prem, do we have to pay for that traffic?
From the cloud to on-prem, in this case, yes. So the outgoing traffic that goes from the Azure Data Center into on-premise, yeah, you have to pay for that. Okay. And if there are questions about how much, there is in the portal information about the different limits and how much you have to pay for those.
Okay.
All right. In terms of how do you go and configure this? So we have many technologies today already on-premise that people have been using to enable disaster recovery, and they can continue using this for these, we call it hybrid scenarios, where your replicas are in Windows Azure. So you can do this, for example, through availability groups, again, right? You can do it through database mirroring, or you can do it through log shipping. So people who have been using log shipping, they can use that as well. Here, in terms of zero data loss, you could, in theory, achieve zero data loss if you want to. The reason why we mark it as no here is because in general, when people configure disaster recovery solutions between data centers, they configure these replicas as asynchronous.
Okay.
And the reason why they do that is because they don't want to block transactions on the primary, waiting for acknowledgements back from the secondary saying that the transaction is stored safely there. In some cases, it may be possible. For example, if you're very close between the data centers, if you have less than 20 millisecond latency, for example, you may be able to configure that. But in large majority of cases, you don't want to have any impact on your performance on the primary, so you configure this as asynchronous. And what this means is we don't block transactions on the primary. We send them continuously to the secondary. But it may be possible that the secondary may fall behind, right? For some reason. For example, there may be a network glitch. What that means is that if at that point in time you try to do a failover, it's possible that there may be some data loss, right? And obviously you have all the information in SQL Server about what was the last transaction time, what was the last transaction, even the last transaction sequence number that was committed in that secondary. And that's how you can compare that and take a decision if you want to failover or not. So we talk about database mirroring, we talk about log shipping. There are different advantages for availability groups. First one is you have an integrated solution for high availability and disaster recovery. So you can have, for example, one replica for high availability in local data center, and then you can have one or more replicas in Windows Azure, and you have a single solution to configure and manage and monitor. So that's a very powerful statement there. You're able to offload read workloads to Azure. This is very important, for example, for people who have reporting applications that want to move those out of the primary. If you put your secondary in the cloud, you can start changing your connection strings and pushing those reporting workloads there. Right? Many people I have seen they actually migrate some of these applications into the cloud and then just run them against the local secondaries in the cloud just to reduce even more the latency, right? Okay. So something else that you can start looking into how you architect these new hybrid applications. You can offload backups to Azure. Again, this is very powerful capability. Many customers would like to have backups outside of the data center so that they're always available in case that the data center becomes unavailable and they can go back in time, for example, to a restore. They can do this by taking some of these backups on the secondary replicas of an availability group. Okay. So powerful capability. Again, in the case of availability groups, we have the requirement of Windows cluster, right? And this means that that secondary in the cloud and your on-premise SQL Server need to be running in the same Windows cluster, and because of that, they need to be running in the same Windows domain. Okay. Right? Now, to achieve this, if you want to make sure that those secondaries can be part of the same Windows domain as on-premise, you need to configure what we talk about. This is the site-to-site tunnel, and you can do this using a VPN device or Windows Server remote access services. So actually, I think it's a good point now to go and show some of the tunnels and see how they look from the portal. So let me close this. So in the portal, if you go to networks, right, we'll see that we have some tunnels here. So let me show you an example of this. So we can go here into the dashboard here for the tunnel. And it'll give us some information about the tunnel itself. The way you configure this tunnel is you go into Windows Azure and you specify, you define basically a virtual network where you specify an IP address range, right? So you say, I want to define a virtual network. This is the lower bound of the IP address. This is the higher bound. And then you can generate a public key, right? That public key is a public key that you can go and use on-premise to configure your site-to-site tunnel. And you can configure that, again, using VPN physical device, or you can just configure this in Windows Server Remote Access Services. Once you do that, you have what we see here in the screen. So this will show you, for example, that on-premise, I have connectivity here. If, for some reason, connectivity goes down, this is shown as a red line. But in this case, basically green means that connectivity is successful right now. And then we have the virtual network that we described before in the cloud. You have information about all the data that has gone into the cloud, all the data has gone out of the cloud. There is an IP address for the gateway where you connect to, right? And you can connect to that IP address. We have some information about all the virtual machines that are part of that virtual network. And what this means is you can access all of these virtual machines as if they were part of your on-premise domain. I see. Right? You can even authenticate to those virtual machines using your domain credentials. So very powerful capability. They have an IP address in the context of the virtual network as well. And then let's see if there is anything else interesting here that we want to show. I think for now is good enough. So let's go back to the presentation. Okay, let's see what else we have here. So this is how a sample deployment looks like. So on the on-premise environment, for example, I can have my SQL servers running. So I have here, for example, my primary, right? I have my secondary. They're part of the same availability group, and that's how I achieve high availability, right? And then on-premise, I have my Active Directory domain controller. There is a VPN device, right? And that VPN device establishes the tunnel to the Windows Azure gateway. In the cloud, now I can have one or more secondary replicas, right? And these secondary replicas become part of the same availability group and become part of the same Windows cluster. Right? Something that you'll notice is the DNS suffix of machines in the cloud actually have a different suffix than the one that I have on-premise. Right? And that's how you can distinguish this, for example. So in on-premise, I'll have my redmond.core Microsoft domain, whereas in the cloud, I'll have something like US West, or the different regions where I put it, and then cloudapp.net, etc. Right?
So this is all good, and some of the customers that I have here, they're not familiar that much with Windows Azure as much, but they're familiar with SQL Server and always-on technology and all that stuff.
Right.
When we come up with this solution that allows you to have DR in the cloud, anything we can do to help them to get to the Azure faster without have to learn all about Azure and all that.
Absolutely. So before running into the demo, something that I wanted to show is let me go here. So SQL Server, high availability in Windows Azure VM. So here we'll find all the documentation associated with all the scenarios that we have been talking about. So you just search and you go into this site, you'll find information about all the different scenarios. So for example, we'll talk about high availability, right? And you can look at how to do this through availability groups, right? How can you issue high availability, right? And then how can you do it through database mirroring, right? Then we'll talk about disaster recovery solutions, right? So again, we talk about how can you do this through database mirroring, how can you do this through backup and restore, for example, Windows Azure storage. Then for disaster recovery solutions in hybrid scenarios, where you want to have these replicas in the cloud for your on-premise environments, we show you how to do this again with availability groups, right? So you have tutorials and information for this, and also for database mirroring, as well as for log shipping, and even with backup and restore to Windows Azure storage. So we have all this information in place. I think this is a great way to go and start familiarizing yourself with all of this. We have all the tutorials on the left side. We have tutorials using graphical screenshots, for example, so you can look into how to do this, all these steps using these tutorials. And it talks about how to configure a domain controller, for example, how to create the virtual machines. What else do we have here? How to create a Windows cluster in the cloud, right? How to go and configure the availability group, right? So we have all the information here, very detailed tutorial with all the screenshots. For people who are more familiar with PowerShell, we have the tutorials with PowerShell as well. So you can go here and they can use some of these tutorials, right? We even have a script, a PowerShell script that configures high availability end-to-end. So people who want to do it in the simplest way, they can just go and run the PowerShell script and it will do it for them.
Okay, awesome.
Right?
Very comprehensive.
Yes. So I think at this point, let's go back to the presentation. There's a couple of cool things that I want to show. So let me move forward and I'll show some of the things that we have in SQL Server 2014, CTP2. So many people may be wondering, so how do I go and add this replica in the cloud?
Right.
I show you the tutorials. You can go and do that. You can go and do it manually. In SQL Server 2014, we're going one step further, and we're really, really simplifying how you can go and do this. So let me talk about, I think we talked about this one already, why you want to go and add replicas in the cloud. We talked about this. What I wanted to show is this demo. So in SQL Server 2014, we're simplifying how to add this replica in the cloud through SQL Server itself. So let me go and show you this. All right, so what you have here in the screen, right, is an availability group. We have, well, actually you have many availability groups, but I have one here in particular that I'll be using, AG. The availability group has a couple of replicas already, right? Primary and secondary for high availability, and it's protecting one database, right? DB5. Now, you can see in the dashboard that these replicas are configured for automatic failover, right? That they are synchronized, right? At this point in time, I could go and add another replica. Let's say that I want to add a replica in Windows Azure. So what can I do? So I can click, right-click on Availability Replicas, and then I have Add Replica. Add Replica will bring the traditional wizard that we have since SQL Server 2012 for adding a replica to your availability group. It's the same wizard as before, but now we have added a new button. A new button is called Add Azure Replica. If I click on this button will bring this screen, which is very similar to the screen that we have in the Windows Azure portal.
Okay.
And this screen will allow me to connect to Windows Azure, specify my credentials, and after that, specify, for example, the size of the virtual machine that I want to provision in Windows Azure. So the first thing that I have to do is connect to Windows Azure. So if I have connected in the past, it will remember my credentials, and I don't have to do it again.
Right.
But if I have never connected, I can go and sign into it. So I can specify my live ID credential, for example. Right? And then once I specify that, the wizard will automatically download a management certificate that I can use to authenticate all the operations that I do to Windows Azure. And it also downloads a list of subscriptions. So with my live ID account, I may have multiple subscriptions that I want to manage. So I can select which of these subscriptions I want to use. After that, I click Connect. And it'll take a little bit of time for the wizard to connect to Windows Azure. Once it connects, it downloads the list. It automatically populates some of these fields with information from my subscription. So for example, it will download the set of images that I have available in the system. It will, by default, select the best image. So it will detect what operating system I'm running, what SQL Server version I'm running, and it will select that one by default. Okay. I can select different sizes of virtual machines. So again, I can go from a small one to the very large one with 8 cores and 56 gigabytes of RAM. I can give a name, for example, to my virtual machine. I can specify again my username. The same things that we did before in the portal, now I can do it through SQL Server itself. Right? So this shows the integration between both the SQL Server product and the Windows Azure cloud provider. And then I can select in which region I want to create my replica. Right? So I can put it, for example, in Central US, West Europe, etc. If I want to, I can put it in a specific subnet. After that, I need to give it a credential for my domain that has permissions to add a machine to my on-premise domain. Right? Because I need to be able to add that virtual machine into my on-premise domain so that it can become part of the domain and part of the same Windows cluster. Right. So I give it a domain credential here for my Redmond domain. Right? I give it my password. After that, this secondary is added to the list of secondaries that are in the system. I can configure it as readable if I want to, and just by configuring it as readable, my applications can connect and read from that secondary. Okay. The next thing that I do is I specify how do I want to move my data, my copy of the data from on-premise into Windows Azure. I have different options by default. We select full, and full basically means I'll take a full backup from my database, and then I share that in a network share, and then I restore that from the share into that virtual machine in the cloud. Right? How long this will take, it will depend on the size of the virtual machine. Sorry, not on the size of the virtual machine, and the size of the database on-premise. Right? After I do that, the wizard will go and do many validations for me, right? As you can see, it's a complex setup, it's a complex environment, right? And the wizard wants to ensure that I have success at the end of it. So we'll go and validate things, for example, like ensuring that the image of the virtual machine that I select is appropriate to support all availability groups, for example. It will verify that I have enough space in my storage account in the cloud, that we talk about the cloud service and how it's a container for MySQL server, that cloud service is healthy, right, that is running. It will check, for example, the, what else it will check? That the VM size supports the number of disks that I require. So again, different VM sizes support different numbers of disks. So it will look into my on-premise configuration. It will look at how many disks I have, and based on that, it will make sure that that size that I select in Azure can host all of those disks, right? And it will check the compatibility level between the primary and the secondary and all that.
Right.
And after that, it'll show me all the choices that I did in the wizard, right? So it will show me, for example, the backup location, the name of the virtual machine that I'll provision, the location, like Central US in this case, the size of the virtual machine, etc. It'll show me information about the disks that will be allocated for that virtual machine, etc. And at the end of this, basically, the wizard will run. Again, how long it takes, it depends on the size of the database. Provisioning the virtual machine takes around 8 minutes right now.
Okay.
There's always work trying to reduce that time. And after that, the main thing is restoring the backup from on-premise to the cloud. Once you finish that, basically you have a replica in the cloud that is synchronizing from on-premise. So very powerful mechanism of how you can go in a simple way, go and add this replica in the cloud.
Okay. So it takes away all the complexity of, you can do it manually, like
Absolutely.
you have a tutorial, you can do it manually,
Absolutely.
but this one will help you a lot.
Yeah, so people, for example, that are running still on SQL 2000, even 2008 or 2, for example, you can even go today and configure a database mirroring session, right? And you can add your replica in the cloud. People who are using availability groups in SQL 2012, they can go and do it manually, right? People who are in SQL Server 2014 can now leverage the wizard to do this in an automated way.
Right. Okay, great.
So let's go back to okay. So let's go back to this one. All right. So at this point, I just wanted to again let people have some time to look at the resources, some of the things that can help them go and start becoming familiar with these scenarios that we have discussed. The first place to go is the place that I showed you, the SQL Server HADR on Windows Azure. We have all the tutorials there, all the scripts that you can use. If you want to become familiar with some of the other aspects, for example, how to create a virtual tunnel, there is also a site that you can go to. Finally, if you want to learn, for example, how to set up an Active Directory domain controller in the cloud, there is also a tutorial for that. So if any of these scenarios are you want to go and play with, then go into each of these sites.
Yep. Well, they have a chance to download the PowerPoint so they can look at the links and all that.
Okay, good.
Well, thank you so much, Luis. Thank you for today's session. Hopefully everyone will learn a lot about this session. And we'll take 15 minutes break right now. And we'll be back with another super exciting session on SQL Server 2014. Thank you, guys.
Thank you.
Welcome back, everyone. My name is Darmadi Komo. Welcome to another session on SQL Server 2014. Today we're focusing on the hybrid cloud scenarios. And today I'm very glad to be joined by Sung here from engineering. Sung, we talked earlier before this session, and you tell me that you're going to share something weird, some mind-bending stuff. So tell us what you're going to share today.
Sure. Good morning, everybody. My name is Sung. I'm going to talk to you about SQL Server data files in Windows Azure. So let me first introduce myself a little bit. I am a program manager. I've been in SQL Server for around 8 years now. I've worked in various spaces in SQL Server, including the security space, where we worked on some encryption technologies, including transparent data encryption. I've also worked in high availability, so I've done some work with the SQL Server failover clustering. And I've also worked in the virtualization space. So I wrote a consolidation white paper for SQL Server using virtualization technologies. And I'm currently working on SQL Server running in Windows Azure Infrastructure Services, which is SQL Server running in a Windows Azure virtual machine. So a quick overview of what we'll talk about today. I'll give you a brief description of the technology. We'll talk about some of the scenarios, and then I'll show you how to use it. So SQL Server data files in Windows Azure. It's a kind of a new and interesting technology. You might be familiar with having your music files or your video files streamed from your internet. Well, SQL Server data files in Windows Azure lets you stream your database files and your log files from the internet to either your on-premise SQL Server instances or your SQL Server instances running in Windows Azure virtual machines. What this allows you to do is it lets you create and place your database and log files directly in Windows Azure Storage. Now, why would you want to use Windows Azure Storage? Windows Azure Storage provides you with nearly bottomless storage. You can use many, many terabytes for pretty cheap. And you don't have to manage it. You don't have to worry about it. You don't have to maintain it. We produce replicas for you. We maintain high availability of that data for you. So you can place your data on there and not have to worry about any of the administrative costs or any of the maintenance costs that are typically associated with maintaining data and storage. They, of course, protect you from loss, and we can persistently provide this to you. The other things that we provide you for is it provides you with some basic disaster recovery capabilities. So, for example, if you have your SQL Server instance running in a East US environment, you can actually have your data located in West US or maybe in another continent. So if anything should happen to your SQL Server instance running in East US, you can simply reattach a new instance and have data running again in your other environments.
Wow. So hang on for a second.
Sure.
So you're talking about putting my data files and my log files from my SQL Server in Azure storage while my SQL Server is still running on-prem?
Yeah, that's right.
This is counterintuitive. Why would I want to do that?
It is. It does sound counterintuitive at the beginning. If you first think about it, having your SQL Server and your database files not co-located together seems weird and seems a little bit odd. But I think there are certain situations where this could be useful to you. For example, if you need to rapidly move your data from location to location, you can actually have your SQL Server instance running anywhere, and your data is always in the same place. So anywhere where your SQL Server is running, you can simply then just reattach the data that's running in the cloud, and you can be good to go. In addition, you separate your concept of compute and storage. So because your compute and storage are separated, this lets you upgrade your compute at your leisure and still have the storage still be in the same place, and you can connect to it at any time.
Wow. Okay. Interesting. I'm sure our audience have the same questions. I have two questions that pops in my mind. The very first one is, how about performance?
That's a great question. So if you actually are running a SQL Server within the Windows Azure virtual machine itself, performance is actually not too bad. As you know, if you run SQL Server in Windows Azure virtual machine, all of your data gets stored into Windows Azure storage anyway. So all of the local disks are actually backed by Windows Azure storage. So the performance in that scenario is actually pretty equivalent, and in some cases maybe a little bit better because you're directly talking to the Windows Azure storage backend. If you're running on-premise, however, you will experience some network latency, and so your performance is probably going to be a little bit worse than what you are used to and what you may experience. Again, but this very much depends on how you set up your environment, how you set up your network, and how you have set up your storage. You likely will have lower latency, however, which means that your I/O will be slower. So if you were to use SQL Server data files in Windows Azure with an on-premise instance, you probably want to fine-tune your workload, maybe pick something that's not as I/O intensive or is primarily read workloads rather than having a lot of write workloads.
So test the latency first. I guess that's the
yeah, exactly right.
test the latency before trying this thing. Okay, the other question that I have is the security, right? Everybody's thinking about security, like why would I want to put data files in Azure?
Yeah, that's a great question.
Right.
You know, like database files are usually particularly sensitive. You might have personal information, you might have financial information on there. Your data is protected in several different ways. First, Windows Azure Storage itself provides a mechanism for securing your data. So there's this concept of these storage access keys. And you have to have a storage access key to even access this data in the first place. So somebody without the storage access key cannot access it at all. Additionally, you can use several mechanisms within SQL Server to protect your data. You can choose to use our various encryption options. We have both granular encryption, which is using our built-in functions to encrypt cell by cell, or you can take advantage of transparent data encryption. In both of these cases, the beauty of using this is that you actually have your keys wherever your SQL Server instance is. So if you still are on-premise, all of your keys and all of your decrypted data stay with you on-premise. But when they actually get stored into Windows Azure Storage, they are fully encrypted. So they are encrypted before it gets sent over, and they get encrypted at rest. So all of your data in Windows Azure Storage itself is fully encrypted, and you only have decrypted data when you actually are on your SQL Server instance.
Wow, so I can store my key or certificate on-prem, making sure that I kept that safe while I'm putting the data in Azure.
Yeah, that's exactly right.
Okay, wonderful. Okay, I'm sure you tested this with a number of customers, early adopters, things like that. Can you share with us what are the common scenarios? I'm sure they all want to know.
Sure. Let's actually walk through one of the scenarios. So I have here, you have your basic setup. You have a machine. Let's call it Node 1. This machine could either be running in Windows Azure virtual machine, or it could be running on-premise. And you have your SQL Server installed on it. Of course, you have your Windows Azure Storage. And let's say now you've created an account with it, and you create a container. So this gray box represents a container within Windows Azure Storage belonging to your storage account. On your SQL Server instance itself, you create what we call a credential. This credential stores your access information. Remember, we talked about that special key that you can use to access the Windows Azure Storage container. Your credential stores that key in there. And now you create a database. So the database is logically on your SQL Server instance, but it is physically stored on Windows Azure Storage. Now, because it's on Windows Azure Storage, we have multiple replicas of that data for you. So as you can see here, we have now replicated that data 3 times. So in case if there's any sort of error or media decay or anything, we have that protected for you. Let's say something happens. So this goes to your question, Marty. What's the scenario here? Let's say that instance goes away. There's a disaster that occurs. That machine melted. Who knows what happened to it, and it just disappeared. Now, you can actually create a whole new instance somewhere safe, hopefully. You have another machine. Let's call it Node 2. You have SQL Server back on that machine again. And you do the same thing. You create that credential that we previously created. And now all you have to do is issue an attach command to the existing data that you have on Windows Azure Storage, and it's working, and it's up and running, and you have that that node and SQL Server backup and available and in production relatively quickly. As soon as you can set up that instance, you can attach it, and you're back to where you were before.
So it saved me time from even like restoring from my backup, because this is just a simple attach operation. Exactly.
Not only does it save you time, it potentially gives you a better recovery point objective, because your SQL Server instance was live at the time that it potentially went down, and all of the data was being immediately stored in Windows Azure Storage. When you get your new server back up and running, you are actually back at that point where that previous server went down, because all that data was live stored on Windows Azure Storage.
Okay. Another question just popped in my mind.
Sure.
How about the pricing? We have the data files in Azure. The database is running 24/7. Does it mean that every transaction that I send there, I need to get charged by Azure? Is that what it is?
Yeah, great question. So there's two costs that you'll incur by using this feature. So the first is the actual storage of the data itself. So you pay per gigabyte that's stored on there. So if you store 100 gigabytes, you'll pay for the 100 gigabytes. Transaction-wise, any transactions that are within the Windows Azure boundary, you don't pay for. So that's just part of our feature. You don't have to pay for any transactions on there. So if you actually were running within a Windows Azure environment and you had a Windows Azure virtual machine, then your costs, you basically just pay for storage at that point. If, however, you were to be using on-premise, like we were talking about, then you would pay at a per transaction. Each time you initiate a transaction, you do pay a cost. This is very low, though. We anticipate that the transaction costs are, several cents per month for a relatively small database that's not running very often.
Okay, that makes sense. Okay, so I'm slowly kind of understand what this scenario is all about.
Sure.
Is it really hard to configure this thing, or how is it? Is it very complex?
That's a great question.
Yeah.
So it's actually very easy to configure. All you have to do, basically, is you create a credential. As you can see here, create a credential with your key information that's stored in the credential. After that, use it just like you would use any other DDL statement. So basically, you use create database, you use create backup. Any of those statements are exactly the same as before. The only difference is that instead of the local path, you would use the URL to your Windows Azure storage account. And it's that easy, and very little changes. In fact, you most likely won't even need to make any application level changes, because all you need to do is have pre-created this credential, and then of course change any of the relevant file path strings. And you're back up and running, and it's working, and you can use use it as if it's any other database stored any other location. And in fact, it'll look like any other database in terms of usage and in terms of how you access it and how everything is stored and used.
So it's very simple. It looks like it's very simple. It's just like regular create database. Plus, I don't need to change my application.
Right. Yeah.
In that sense, right? Okay.
Yeah.
Okay,
Yeah.
awesome. Can you show us how it actually runs?
Sure. Absolutely. So I have this environment created. So you can see here, I have a SQL Server instance that's up and running. On here, I'll go through all the steps of creating a brand new database with all of its data files stored in Windows Azure Storage. So you'll see here, the first thing that we need to do is actually create the credential that contains the information that you have, the SAS key. So as you go, I'll run it. And I'll give you a quick idea of what this looks like. So you can see here, I actually have two credentials in the system currently. The first one is, you may have previously seen a previous session talking about the backup to Windows Azure. So there's a credential here for using backup to Windows Azure. Very similar concept. And then you'll see here, there is the credential that we just created for using the data files on Windows Azure. You can see the name of it is the actual URL and the path. And you can see that we specified it as a shared access signature.
Can you talk about shared access signature a little bit? Like, what is that? And I saw there's a secret thing over there.
Yeah.
How do you get that, and how do you obtain that from Azure?
Yeah, great point. So there are actually two types of storage keys in Windows Azure. There's what is called a shared storage key, and there's a shared access signature key. The shared storage key is actually kind of like an admin key. So you may be already familiar with using it because backup to Windows Azure uses the shared storage key. This basically gives you full control over your storage account. The shared access signature key is a granular key. What it means is that it allows you to have a more granular access to the container that you created and that you specified. So you're allowed to do special permissions on it. For example, you could create a shared access signature key that is only available for reading data, or you can create an expiration on it. Like all shared access signature keys expire at some point. So you have better control over who has access to your data and how you have access to your data. And it's only at the container level. So a shared access signature key can only be used to access the container that it was specified for. You can get this by having, either writing your own tool or using a third-party tool to generate it from the REST API. Unfortunately, right now, you can't directly create a SAS key from the portal, so you'll have to use one of these third-party tools. But all of these tools, they do the same thing. The SAS key is actually generated by Windows Azure itself, and these tools just call into the REST API that Windows Azure provides to generate the SAS key on your behalf, and then you can then access the SAS key.
Okay.
So it's a good point. You will have to use one of these tools, however, to create the SAS key so that you can use this feature. You can't use the regular shared signature, the shared storage key that you get through the portal. That one is too high level and it gives you too much permission. So you actually have to use one of these third-party tools to actually get get this key.
Okay. Right. So you have to use the shared access signature key to run this thing.
Right.
Yeah. Okay.
Right. And that's primarily, again, for security reasons, because we only want to have the SQL Server instance be able to access that one container. We don't want it to have access to your entire storage account. And we also want to make sure that if you want to provision multiple SQL Server instances using the same storage account, you can give them a degree of isolation by giving them separate SAS keys and separate containers so that they can't actually access each other. And it gives you an extra level of protection for your data.
Okay. Awesome.
Cool. So with this created, we can now create a database. So you can see here, the only change to the create database syntax is actually on the URL itself. So the URL has been changed to be the storage account, and the container itself is called SQL Pass. And before I actually create it, let me first show you what it looks like. So in Management Studios, we provided this Azure Storage browser. You can see here, I already connected to the Fabricam storage account. There's a bunch of containers that are located here. The specific container that we are using is called SQL Pass. And you can see within here, there's currently nothing at all it's totally blank.
So this is a way in SQL Server Management Studio to connect to Azure Storage without going through the portal.
Exactly.
So we build that into Management Studio.
Exactly.
Okay.
Exactly.
Okay. Awesome.
Yeah. So this provides you convenience. So rather than having to switch into using your browser, then logging into the portal and viewing it, you can just go from one place here and view all of your your blobs and your data files and such forth.
Right.
And
I assume that you get the same view here and then the Azure portal.
Exactly.
Okay.
Yeah. Exactly. So let's go ahead and create this database file now. Takes a little bit of time. It's communicating over the REST API to the Windows Azure and running. And it's what it's doing now is actually creating the blobs. So it creates two blobs on Windows Azure Storage. It creates both it creates the traditional database database file, which is stored as a blob, and then it creates the log file, which is also stored as a blob on it. See, it completed successfully. So if we go back here and refresh, and reopen these containers, and reopen SQL Pass, you now see we actually have these two files that are now located on Azure Storage. Let's see what it looks like to SQL Server. So I'll just do a basic query from the master files list. So you can see the existing databases that we have on the system. There's a bunch of files on here. So you have the master database, tempdb, and you can look at this new database that we created, foo. It looks the same pretty much as any other ones, except when you get the physical name, you'll see that it now contains the path to the Windows Azure Storage account that we have. And it also has a credential ID. This lets you know which credential has been used to access this, so that in the future, if you need to reference it, if you need to change it, you can go here and look at it and then match it back to the credential that you used.
So you treat it as if it's a local database.
Exactly.
Just like before, it's just now pointing to Azure.
Exactly, right. Exactly. So for all intents and purposes, it looks just like any other database, and it looks as if it's just any other locally stored database.
So all the operations that we can do with the database, it should work exactly the same here.
Exactly right. In fact, let's go ahead and let's actually use this database, and let's create some data in it. Let's put some data into it. So let's switch to using this database. And I'm going to create a table that just contains some information. So let's say this is like some customer table that you're storing with customer information. So just insert some data, and let's select from it. So as you can see, it's just like any other database. But let me show you the power of actually using data files in Windows Azure. Let me now detach this database, and let me show you how easy it is to actually have the exact same data running in a totally separate instance. So let me switch back to master and detach this. And you can see here that the database is no longer on this system.
So what happened to the files?
The files, they're still stored on Windows Azure Storage, and they're still there. In fact, let me show you this. Let me now switch to a different machine. So I have a second SQL Server instance that's already set up and running. You can see here that this does not have any of the credential created. This does not have the database created either. So you can see here the database has not been on here. So the first thing to do again is recreate that credential with that SAS key.
The exact same SAS key.
It has to be exact same SAS key because it's basically the exact same access information. And at this point, now let's attach that database that we just created on Windows Azure Storage. So you can see again, it's the exact same syntax. The only difference is the location again of the files. And lastly, we're now specifying for attach this time. So let's go ahead and attach that. And in this case, this is now going, one of the things that it's doing is it's acquiring a lease. So each of the files on Windows Azure Storage has this concept of a storage lease or a blob lease. What this means is that when one application or one system has acquired the lease, nobody else can actually touch or modify those files. This primarily is actually just for transactional reliability, so that you don't accidentally have multiple processes trying to modify these files at the same time. But it also gives you a level of security, because nobody else can be maliciously modifying your database files while it's being attached to your system, because SQL Server does in fact acquire a lease on top of it as well too.
So this is like very similar to the file system that we have on
Right.
Windows.
Right.
Have a lock on the file header.
Exactly. Yeah, that's probably the best way to think about it.
Yeah.
It's actually just like acquiring a file lock on a local system, so that no other process can actually be accessing that file at the same time.
Okay, awesome.
So we have that file attached now. We have that database attached now. So if you see here, you can actually see foo has now been attached to the system. It's actually now up and running.
And it's on different SQL Server instance.
It's on a totally separate SQL Server instance. And in fact, let's show you that all that data is still there. Let's use that database again. And you can see this is the data that we just previously inserted. It's all back up and running. And on the second instance as well too, this is the same view as you had before of the storage. And of course, it can also see the files. Nothing changed. It was always there. It was always up and running. There's some more advanced stuff that you can do here. You can enable, like we mentioned, transparent data encryption. So at any point, you can actually have just created a certificate here, enable transparent database encryption, and then turn on encryption as well too. So anything that you're running, anything that you're storing will be stored all encrypted into the system itself. You don't have to worry about it, and there's nothing else that you need to do. This gives you, a lot of flexibility and power. There's a number of scenarios where you can actually use this sort of thing. For example, one of the other things that you can do with this flexibility is if you had some sort of, back-end office where you're running, where you have your main data storage, you're maintaining the data, and you have maybe branch offices. So let's say you have smaller branch offices, or maybe even Salesforce or salespeople who are traveling and they need access to the data. Well, all of your data can be centrally managed and centrally stored and kept up to date and administrated directly from your back-end location, your central location. And then as needed, these branch offices or these traveling salespeople, they can fire up the SQL Server instance, and all they have to do is they just have to attach their database. Like I showed here, they just have to attach these databases from the cloud, and they instantly have access to the latest information, to all the latest updates, whatever changes that you made in the back end to keep it consistent and current. They have immediate access to all of that, and they don't have to worry about managing any of it. All they have to do is attach it and start using it, and you're good to go.
Okay.
So, this gives you a lot of flexibility. This gives you a lot of power. And you can even come up with other interesting ways to play with it. Like, for example, let's say you have a database that, has some enterprise level features, but you don't need to use those enterprise features all the time. Maybe you only need to use it like an hour out of the day, and then the rest of the time you just need to use maybe standard level features. Well, you can play with it in Windows Azure, for example, by creating like a enterprise instance. Only attach this database to that enterprise instance as you need it, and then shut down that enterprise instance, and then reattach that database to a standard instance or something else, so that you can continue using that data and not have to worry about having to pay extra money for the enterprise costs if you don't need that SKU and if you don't need that functionality.
Wow, this is very interesting, because now you can actually use multiple editions of SQL Server attaching to the same data files.
Right.
It works across different editions as well.
Right, exactly.
I do have a question on the transparent data encryption.
Sure.
So if I turn on data encryption on one, save my certificate or my key on-prem, when I want to attach again, does it mean that I have to restore the key back and things like that? What's the process there?
Yeah, you're exactly correct. So transparent data encryption, of course, provides you with an additional level of security because you need to actually have that same information, that same certificate, in order to be able to access that data on your second instance. So in this case, if you were to set up 2 instances with transparent data encryption, what you would need to do on the second instance is, and this is similar to how you would normally do it, even without data files or Windows Azure storage. You would have to have the exact certificate that you created on your first instance, export that certificate, copy it over to your second instance, restore it on your second instance, and then you'll be able to access that database. Because what happens is, you'll be able to physically access those files because you have the SAS key, but the second instance won't be able to decrypt that data until you actually have that certificate on there. So once you have the certificate on there, it'll be able to decrypt it and it'll be able to run as normal. But it is something that you definitely have to be careful of and make sure you are using the same certificate in both places to get access to that data.
Okay. One final question that I have is, in the previous slide, you talk about the delayed durability, things like that. Can you talk about why we want to have that available for this?
Sure. Let me switch back to that. There are actually 2 interesting features that you can use with data files in Windows Azure, and it kind of goes to your point too. What about that what about that connectivity latency? What about performance?
Right.
So there's 2 features you can use to actually help mitigate some of the performance issues that you might experience. The first one is delayed durability. So delayed durability is a new feature in SQL Server 2014. And what this does is it postpones some of your log writes. So when you make a transaction to the database, typically what happens is we wait for that transaction to what we call harden. This means that that transaction is fully committed to the log, and even if that server were to crash, we would be able to recover from it. With delayed durability, if you have certain workloads that are not particularly sensitive to having the exact reliable information or the exact information, and you're okay with some potential data loss, what delayed durability does is when you perform a transaction, it'll immediately return from that transaction without that transaction hardening. That means that that transaction may or may not have been written to the log file. So if there was a crash, for example, you may actually lose that transaction. But what this allows you to do is you no longer have to wait for that write. You don't have to wait for that write to the log to complete for that transaction itself to complete. So this allows transactions to go much more quickly, and it significantly reduces your write latency, which is, again, one of your potential concerns with using data files in Azure, because otherwise you would be waiting for that whole round trip. That write would occur, the transaction would be committed, it would be written to the log, and then the transaction would return.
Right.
So with delayed durability, you don't have to wait for all of that. It just comes back. And so you can mitigate some of the write latencies that you might experience with delayed durability. Again, this is only for workloads that you feel you might not need to have, that you're okay with potentially losing some of the transactions. And so if you have those workloads, then this is a great candidate for using them both together.
Okay. Awesome.
How
about the other one?
The
column
other
store.
feature, column store. Column store index is also another new feature. This lets you actually have a lot of your index in memory. So with this feature, you actually don't even need to go and do that round trip to Windows Azure Storage at all. So this actually saves a lot of potential latency because you actually have all of your data loaded in memory. And then any additional queries that you do against it are done, of course, against your in-memory index.
So you don't touch the disk at all.
Exactly. So you don't have to pay for any of that network latency. You don't have to wait for any of that read. You don't have to wait for any connection drop issues or anything like that. It can be very powerful when combined with data files and Windows Azure Storage because you have the power of having multiple terabytes of data stored in Windows Azure Storage, but you have relatively quick performance because you have your all of your data, your index being read from memory, so your queries can run very quickly as well too.
I see. Plus, data warehouse data usually is not updated very frequently, maybe like once or twice a day in a batch format.
Right.
And this will assure that we don't actually read a lot from the disk directly.
Yeah, that's exactly true. This really lets us play to the strength of both features. With data files in Windows Azure Storage, you can store like all these large data files, all the data warehouse files directly in it. And it's the best is when you don't have to access it that frequently, so you don't have to worry about that much network performance, which is really great with a lot of the data warehouse scenarios where you actually are not doing a lot of updates on a regular basis, and it primarily is like a read workload, in which case, data files in Windows Azure Storage provides you a lot of benefit to using both of these features together with that specific workload.
Okay, wow, awesome. Well, thanks for all this discussion. And this is a great features that I think that people can leverage. And I hope that you get good understanding of what this thing can do or cannot do. And it will probably fit with a lot of the scenarios that will help our customers, viewers at home. Thank you so much, Sang, for today, for your session. And we're going to take about an hour meal break from now on. We'll be back here for another session with SQL Server 2014. Thank you.
Thanks.
Welcome back, everyone. My name is Darmadi Komo. I'm your host for this session again. And with me, I have Evgeny from engineering. Evgeny, would you like to introduce yourself and tell us what you're going to cover today?
My name is Evgeny Kirvashev, and I'm program manager in the SQL Server team responsible for the hybrid cloud features. So I will be talking today about some deployment capabilities.
Okay, so what are my options on deploying my stuff to Azure?
Let's talk a little bit about that. So before we'll go into that subject, I just would like to introduce what I plan to talk today. I plan to talk about what kind of different options are existing for deployment today for Windows Azure VMs. What kind of new features we introduced in a SQL Server 2014 for deployment and management. First one would be the deploy database to Windows Azure VM wizard in SQL Server Management Studio. And another feature is a new set of PowerShell commandlets for SQL Server 2014. And the first thing I would like to focus on is the deployment options. And the main reason why I would like to focus on that is to give some perspective for what kind of things are available right now. So talking only about the released features, I'm not talking about the SQL Server 2014 yet because it's still in CTP. If you would like to deploy your own image, you have choice between SQL Server 2000, SQL Server starting from 2008 to SQL Server 2012. If you're talking about the Windows Azure Gallery images, and so sorry, we actually have titles swapped on a slide. If you have your choice for gallery image, you have choice between SQL Server 2008 R2 and SQL Server 2012 running on Windows Server 2008 R2, Windows Server 2012. And the other choices that you have for gallery image that you don't have any choice between options available for you at the deployment time, so all options are enabled by default. But this has both good and bad sides. The good side that you don't need to choose anything. You just deploy your image and everything is ready to go for you. And that includes everything, including, for example, analysis services or RS or SSIS. In terms of licensing, for gallery image, you have choice between paying as you go, and there are multiple editions available as pay-as-you-go options. And you can use your license mobility right if you have an enterprise agreement with SA with us. For your own image, you only have option of moving your license to the cloud. This means that you need to utilize your license mobility right. For gallery images, we refresh images, usually we refresh images on a monthly cadence if there is any need to patch images, so if there is any security updates that needs to be installed related to the SQL Server and the SQL Server image. Sometimes we may skip those updates when there is no patches requiring those, but you can rely on a monthly update cadence like it's what we pushing for. But once you deploy the VM, you own that VM, so you are responsible for patching it. And that's slightly different when you're using your own image, because in your own image, obviously, you're responsible for both creating image, patching it when you need it, and patching the VM when you provision it. And one other thing I would like to mention about your own image, that there are two different things you can do when you're trying to deploy from your own image. You may deploy just an individual VM, and then you upload your VHD, you create a VM from it, and you're ready to go. Or another situation when you think you would need to deploy multiple copies of what you have as a VHD content, then you can use the sysprep to prepare that VHD image as a kind of template for what you're doing. And after running sysprep, you would upload it like you did for individual VM. And when uploading, you would choose that you're not uploading the VM image, you're uploading the gallery image. And that will appear in your personal gallery, and you can create multiple virtual machines from that.
Okay, so you can do it your own image, or you can upload in a gallery. Those are the two choices.
You can use a gallery image that we have provided, or you can use your own image, then you're creating it from the scratch. So gallery image has slightly less flexibility in terms of options, but it's way shorter in terms of time frame. You can use it right immediately, and you will get your virtual machine ready in less than 10 minutes. Mm-hmm. If you need to create your own image, your image preparation time would add to that.
Okay. Well, awesome. So I saw in your course topic you have a wizard that you're shipping with SQL Server 2014. Can you describe to us what it is?
Yeah, so we have a new feature in a SQL Server 2014 called Deploy Database to a Windows Azure VM Wizard. And that's a new wizard added to SQL Server Management Studio. And we had couple of big scenarios in mind when we had been designing it. The first scenario, which is on the left, that when you have a lot of experience with a SQL Server, but you're new to Windows Azure, and you would like to try SQL Server in Windows Azure virtual machine. And the main problem, as we have seen that, and we also experienced that when we faced Windows Azure for first time a few years ago, that Windows Azure is a quite complex infrastructure, and when you start learning it, it may be slightly frustrating. Another scenario which we had in mind is when you already experienced a user for Windows Azure, and you have no problems dealing with it, but you know that some of the operations require additional scripts to be written, and you just don't want to go and deal with creating all those things for simple experiments that you would like to do on Windows Azure VM, and then you just would like to save the time. So we come up with a solution that tries to cover both that scenario, and this is the solution that we call Deploy Database to a Windows Azure VM.
Okay. Well, so I'm sure there's a lot of things that goes underneath the wizard itself. You're going to walk us through how it actually does under the cover?
Yes, and the interesting thing about those things that most of those things, if you would deploy your applications or SQL Server manually, you would be required to do most of those things. Some of those things you can do as a preparation when your data is still on premises. Some of those things can be done when the data is already in Windows Azure, but you would need to do some of those or very similar steps. So I would just talk a little bit about what Wizard actually does behind the scene, and this is different from what you would see in the UI. UI flow is slightly different, but you would understand what it does. So on your left, what you see is your on-premises environment. And you see the two color zones. The darker zone is where your management workstation is, and that zone has a connectivity to the internet. The gray zone where your SQL server resides is your data center, where you don't want to have any direct internet connectivity. So, and we don't want you to change that thing. So we will be running that wizard on your management workstation, because this is where you're running your SQL Server Management Studio from. And the first thing we need to do is take an access to Windows Azure, which is shown on the right side. Windows Azure by default allows access only using the certificate. That means that this is a certificate that should be installed on your machine, and you also need to install that certificate on a Windows Azure as a management certificate. And if you're doing something in an automated manner, there is no way around that. So what we're doing here, we're using Windows Azure Portal to retrieve that, to ask Windows Azure Portal to generate and retrieve that certificate for you. So we access that portal, allow you to log into that portal using your Microsoft account credentials, formerly known as a Windows Live ID credentials. And then we retrieve what Azure Portal calls publishing profile, which is basically XML file, contains newly generated certificate plus few additional management fields like endpoint URLs and the subscription IDs. So we retrieve this data in that form, and that allows us to access Windows Azure. Since that moment, we don't need Portal anymore. And actually, the good thing is that we not only need that portal anymore in that current session, but even in the future sessions, as long as you're accessing this from the same machine and using the same subscription and certificate pair, we don't need that portal. So we don't need to come back to that experience.
So it's only one-time thing.
Yes, per combination of machine, subscription, and the certificates, then it's a one-time thing.
Okay.
So if you change one of those components, you probably would need to go to that experience for one more time, but it's not really frustrating. It's an easy thing.
Okay.
So the next thing, when we can connect to Windows Azure, we can start creating virtual machines. We can start attaching Azure drives to those virtual machines. We can create endpoints, which are basically some kind of holes that you're drilling in Windows Azure firewall to be able to access your virtual machine. And now we're facing the next obstacle. We need to be able to access the components that are running inside the VM. And VM has its own layers of protection that's blocking you from just because you may be a stranger that it doesn't want to get access into. So at this point, we're using another new component which is running on a virtual machine, and that component called SQL Server Cloud Adapter. We call that component and we ask that component to provide us access to that VM. So when we have access to the VM, we can come back to our on-premises environment and start looking at the SQL Server. As I have mentioned already, there is an assumption that SQL Server doesn't have an access to the internet directly. And we know this is the case, and we don't want to change that case. So it would stay as it is. We don't ask you to change any of your security policies. So to work that thing around, we ask you to use another, as we call it, role, because it may be just the same machine. And this is the file share role which is located inside your data center environment. As I'm saying, this may be different machines. This may be a combination of all three roles: management workstations, SQL Server, database engine, and a file share in a single machine. Or they can be any kind of combinations. But those can also be completely separate machines. When we have that role established, we ask SQL Server Engine to put the database backup to that file share. And when this backup is in place, the wizard retrieves that backup from that file share and places it to Windows Azure Blob Storage. Why we use the blob storage? Because blob storage provides us multiple ways how we can recover in case of any failure. So there is a multiple recovery options available for network failures. There is multiple retry policies available for us, and we heavily utilize those. So this is pretty reliable. Also, it's protected. You access Windows Azure storage only using HTTPS, so it's encrypted, and so it's secure and it's reliable. So next thing that we're going to do is we're going to call the SQL Server Cloud Adapter again. And we're going to ask the Cloud Adapter to do a few things for us. First, we will ask Cloud Adapter to initialize your newly attached Azure drive. If you have been trying Windows Azure virtual machines already, you probably know that when you attach the new drive to already existing virtual machine, it came like a completely unformatted drive, like you buying your new hard drive from the shop, you attach it to your physical machine, and you need to do a few initialization steps before you can use it. That's the same case with Windows Azure virtual machines, except that everything is virtual. So we ask Cloud Adapter to format that newly attached drive, and we ask Cloud Adapter to download and restore that content that we placed into Windows Azure Blob Storage. So, and once it's downloaded to the VM and restored, we only need to do the cleanup. And the only thing we owe to you is a report. We need to tell you what actually was deployed, what wasn't, and what are details of those things, especially if you need to take any additional steps.
So quite a number of steps, right?
Yeah.
Yep. So you're going to show us the wizard how it can minimize those steps for us.
Yes, I'm going to show you how you can actually do those things using the wizard. So this is your usual SQL Server Management Studio environment. This is your Object Explorer pane. And all that you need to do is to right-click on a database you plan to deploy, choose the tasks, and in the tasks, you probably know where the deploy database to Windows Azure SQL database wizard is located. So that's new wizard that we added located right next to it. So you see, it is here. Let me right-click again. So you click on it. You're getting the first screen where we're trying to provide you with some short checklist of what you would like to know probably before you're going through the wizard steps. And you can use it or you can just go through the wizard steps. It depends on each own personal preferences. So then you go to the next page of the wizard. And that's the first page when you specify some of the details. First thing you need to do, you need to connect to your SQL Server database instance. And this is a standard SQL Server connection dialog, so you're probably familiar with it already. And you see that once you connect it to it, we populate the database name for you, and if you changed your mind, you can actually go and select different database. If you also remember, I have been talking about the different roles and different machines that can participate in that deployment process. But in that case, because I'm using same machine as a file share, as a SQL Server database engine, also as an environment when I'm running the wizard, I can select just a local drive and local file path as that shared folder. In case when you're using different machines, you probably would need to specify the UNC file path. And all that we need to do here is, after we've done all those steps, is to click next. Actually, what we did when you clicked next, we checked that this file path that you provided to us is readable for the wizard, so wizard would be able to write data and delete your intermediate packages when doing the cleanup. So we're trying to do some checks as you're going through the wizard. So if you would experience some failure, we would try to announce that to you as soon as possible so you could correct that situation on the first opportunity.
So in this case, since we don't see the Azure portal, it means that you already pre-download the publishing profile, right?
Yes and no. So when you will see that wizard for the first time, all fields would be empty. I can clear these fields. This field is not editable, so I can clear it. But yes, everything would be empty, and most likely you would like to start from that sign in button. So that's the button that would be probably most interesting for you. And I can actually show how it will look like. I will not be actually signing in because it may take a few additional minutes, but this is a simple sign-in screen, and that's all that you need to do. And the wizard actually doesn't even see your credentials. They go directly to the Azure. So once you sign in here, we can download your publishing profile. And when you have your publishing profile, what actually happens, it will be, I think it's here. Yeah, so I have pre-downloaded that publishing profile. We will just automatically populate all the data from that publishing profile for you.
Okay.
And if you know that you have your certificate already, you can just select your certificate from the list. And you can copy, paste, or even type your subscription ID in that field. So, and now when we clicking next, we actually starting to access Windows Azure for the first time. So if your subscription ID or certificate wasn't valid for the things that we are doing, you would know about that immediately.
Okay.
And now you're getting to the screen where you need to specify your Windows Azure deployment settings. Those deployment settings are actually allowing you to specify few parameters that you can also specify in Windows Azure when you're creating new virtual machine. And most likely those fields would be empty if you have a fresh subscription, but if you don't, you can select something from here. So when you want to have your new virtual machine, you just type the name, my new VM. And when this VM name is typed, the next thing you need to do is to click on a settings button. If you see there is a dialog box that allows you to choose first the image you would like to deploy that thing to, and we can select that image. You see there's a lot of fields that are probably the same fields that you have seen on a Windows Azure portal. And also the thing I would like to show you that right now I'm deploying from SQL Server 2014, and I selected SQL Server 2014 as a destination. Let's assume that you, for whatever reason, selected the SQL Server version less than you have currently. And if that would happen, let me see if we can move. Yeah. If that would happen, you would see an error here. So we're trying to check the version of the SQL Server on a destination, and you don't need to wait 5 to 10 minutes just to learn that the SQL Server version on a destination VM is not compatible with what you have on a source machine.
I see.
So we're checking that for you. Unfortunately, when you select your own user image, we don't know what's inside, so we can give you only the warning that, hey, please make sure that you're deploying to the VM with the right SQL Server, because you may deploy and only then find that you can't actually go ahead. Another situation is when you would like to deploy to an existing virtual machine, and we will go with that route just because the creation of VM takes some time, and we don't want to just to sit and wait here when this time will pass. You click on the same settings button, but you see different picture. You see the picture when you need to authenticate to that VM, and actually you're authenticating to the cloud adapter. You see there is a standard credential pair, so it's username and password, and also there is a SQL Server Cloud Adapter port. We show the default port, but we recommend you to change the port and use non-standard port because using standard port facing internet is probably not the right idea.
Okay.
So once you typed your credentials, we authenticate to the cloud adapter. And you see here, we populated your database name. But if you remember, it didn't have the 01 in its name before. Why it has it now? Because I have already deployed that database to that virtual machine just a few hours ago. And when Wizard finds that database on a VM, it tries to modify the name of the destination database, that it doesn't try to overwrite an existing database. And there is no option for you to delete, overwrite, erase any data which exists on a VM or on a source machine. So we are not deleting any data, we are not erasing any data, we are not modifying any data. We're only creating new data. So Wizard is especially checking in multiple places that there is no risk for you to lose any data at all. So once you enter that, and if you're not happy with that, oops. Let me re-authenticate again. So if you are not happy with that name, you can just type the different name or say that's a new. So and let's go forward. On the next screen, all that you need to do is to validate your settings that you selected and click the Finish button. And then in a few minutes, maybe in a few hours, it depends on your database size and your connection speed, because those two things we can't control at all, you would see your database deployed. This database is quite small, so it shouldn't take a lot of time to deploy it.
Okay, so while it's deploying, I have one question to ask you. The performance. What's the performance implication on this thing?
So the main performance implications, as I have mentioned already, depend on your connection speed and your database size. We don't control those things. And we haven't seen any visible performance impact from the deployed database Wizard. So far, we haven't seen any specific performance impact.
Okay.
But one thing I would like to mention here is that in case there will be any kind of failures happening, so let's say you have your relatively huge database, you're kicking off your process on Friday and you expect it would be finished on Monday when you come back. And something went wrong just 30 minutes after you left your office. We will do multiple retries for all the operations when we know that operation is recoverable. And for most of those operations, we will retry indefinitely until user would stop us. So if we know this is a network failure, we would retry until you would come back to your deck and say cancel. But in most cases, that would actually mean that we will, after multiple retry, we will just finish the process, and when you come back to your deck, you don't need to worry about anything anymore.
I see.
So, and once it's deployed, you see there is a link to report, and after that, all the things that you need is to close it.
Okay. One more question on the Wizard. We don't see where the file path for the database is, like where's the actual file location is, the data file and the log file. When you transfer over to the destination VM, is it going to maintain exactly the same one? And what if we have, in the source database, we have different paths than the destination?
Yes, we maintain, we try to maintain exactly the same separation between file paths and other things on a destination VM, and we try to fit everything to one drive. So that's basically our biggest size limitation. Right now, Azure Drive is limited to 1 terabyte, so this is why we're limiting database size you can deploy to Azure VM to 1 terabyte.
Right.
And if you have really complicated setup in your on-premises environment, there can be situations when Wizard would not be able to deploy that database for you. But they would be other options. I actually have some topic to talk about that. So there are options related to some PowerShell scripts. So we will come back to that. So just a quick list of benefits related to the wizard. First, we don't expect you to have any Windows Azure knowledge, except that you should probably know that Windows Azure exists. And you need to know how to subscribe to Windows Azure. After that point, we don't ask you for any specific knowledge. We would try to do everything for you. We have multiple retry and recovery points in a wizard, and we will, in most cases, we will retry until you stop us. In case, when we know that we can't recover, we would stop immediately, that's for sure. Wizard never ever overwrite or damage any of your data. So we taken a lot of care to make sure that that would never ever happen. It's currently scalable up to 1 terabyte databases, and that's mostly limited by your connection speed and your Azure drive size. And when you thinking about your deployment performance, mostly that would be limited by your connection speed. The faster connection you have, the faster deployment you would have. And if you try to deploy your database using different tools, most likely you would see the same ballpark performance. So I doubt there will be any overhead related to the wizard.
Okay, that's good. So the next question is, I want to automate this thing. I don't want to like click the wizard all the time. Is there any scripting support? You alluded with PowerShell. Maybe they can mention
Yeah, that's actually really related to the previous question that you have asked me. That what if I have complicated environment? What if I would like to automate that thing for, I don't know, for 10 databases, for 100 databases?
Right.
I don't want to run that wizard for 100 times.
Right.
So, and here I would like to touch a little bit the what we have deployed for the SQL Server 2014 in terms of PowerShell enhancements. So we added few PowerShell scripts, few new PowerShell commandlets that allows you to control access to the SQL Server instance. One thing to mention about all those commandlets, except one, that most of them require SQL Server Cloud Adapter be running on the same machine where the instance is located. So, and it should be accessible for sure, so its port should be available. So that's basically the same technology that we utilize for the wizard I have been talking previously. And this is important thing that this technology is shared because you could expect the same behavior. PowerShell scripting currently doesn't cover the whole set of features that deployment has, but it covers the most important part of the things that deploy database to Windows Azure VM Wizard added. So, and what those commandlets can allow you to do is a few things. So you can get some configuration of the SQL Server, so it can be network configuration, and you can set it. You can restart, stop, and get status of the SQL Server instance. You can change your authentication mode of the SQL Server instance, and you can add or remove your SQL Server related firewall. And actually that's probably the good moment to talk about some of the security thinking that we did for the wizard. So and that's a good illustration of our general approach for that wizard and for the PowerShell. So when you asking the Cloud Adapter to open this port in a Windows firewall for your SQL Server, there's simply no command where you can go to that Cloud Adapter and ask Cloud Adapter to open an arbitrary port for you. Instead of that, you need to go to the Cloud Adapter and you need to know your SQL Server instance name for which you would like Cloud Adapter to open firewall port for. And you ask Cloud Adapter to open port for that SQL Server instance. Cloud Adapter would go to that SQL Server instance configuration, would check few things. It would check first that, yeah, that instance really exists. it checks that this instance has TCP IP enabled, and it checks what port it's listening on. And after that checks, it will only open this specific port on your Windows firewall. So there is no chance that, I know, some malicious script would try to open firewall port for its kind of server components that it think it pushed to that VM before. No, there is no chance for that. We took a lot of care of that.
Okay. Well, you're going to show us how it runs, right?
Yes, I'm going to show you. I have a demo for that. So let's come back to the same virtual machine. I would close that script. And I would only show how one of the components are actually working. And I'm showing that from SQL Server PowerShell, you can do the same thing from just a normal Windows PowerShell. The only difference for you would be that you would need to import SQL PS model, which actually represents SQL part of the PowerShell. And here what you need to do, I'm basically showing the steps that you would need to do. First, what you're creating your password for that you would be using to authenticate against Cloud Adapter, and you need to store it in a PowerShell as a secure string. This is why you're using this convert to secure string. So the next thing you need to do is to create your Windows credential. And when you create your Windows credential, the next thing you need to specify is your account name. And when this account name is created, you have your credential created. You use that credential. You see it's here. Unfortunately, it wraps exactly at the points that I would like to show. So let me try to show. So first it's here. It's the first part. And the second part is here. So unfortunately, as I'm saying, it's wrapped. So another part is here. So it's final part of the credential name. And one other thing I would like to show you that you need to specify the full DNS name of the machine. You see we're specifying that full DNS name of the machine. You need to specify another parameter that's saying accept self-signed certificate. And that's important parameter. And actually you would see the similar parameter in the Wizard UI. That parameter tells the client application that if there would be any certificate which is unknown to the client machine, to the machine where you're running this from, that coming from the assumed SQL Server Cloud Adapter connection, you would like that client to accept that certificate automatically. And why this parameter exists at all? Because some of you may consider that not really secure. It mostly exists for the situation when you have just created your virtual machine, and you know, hey, I have just created that virtual machine. It contains self-signed certificate. So I know this is the case that would happen, and I don't want my script to stop and wait for my input while I'm doing that. So, and the last thing I just would like to highlight in that commandlet that you specify Cloud Adapter public port here. And as it was in the case of the Wizard, it's 11435, it's the default port. But I would highly encourage you to use the different ports. And now let's just run this command. It takes a couple of seconds to return, and you see it retrieves a lot of information from that VM, and that's despite there is no SQL Server connectivity available to that machine from the external world. So it only has that Cloud Adapter connectivity and RDP available. So, and just to do some recaps of what we talked about. So there are few easy deployment options available for SQL Server starting from SQL Server 2014. So main thing is a new SQL Server Management Studio Wizard that I showed you. Other things that there is an improved scripting experience available for you in that SQL Server version, and that's expressed to you as a new set of PowerShell commandlets. And there is a new component which you never interact directly with, but it's really helpful for scenarios like managing VMs, configuring freshly deployed VMs, and so on. And that component called SQL Server Cloud Adapter.
Okay, the SQL Server Cloud Adapter, it only exists in the gallery, right, that you create SQL Server on?
Yes, right now it only exists as a part of the SQL Server image available in Windows Azure Gallery, but later we plan to make it available for separate download once SQL Server 2014 releases.
Okay, awesome. All right, thank you, Evgeny. Hey, thank you everyone for attending this session. I'm very happy that we can have this wizard for part of SQL Server 2014. Thank you for attending this session again. My name is Darmadi Komo, and thank you for this. I will be coming back in 15 minutes. Thank you.
Thank you.
Hi, and welcome back. Damarty has stepped out. Adam and I are going to talk to you about SQL Server data tools for Visual Studio. I am Eric Ellis. Adam Mahood will be doing the demos. Hi, Adam. So we are program managers in the SQL Server Database Systems group inside of Microsoft, of course. We work on the engineering team. We're engineering leads for the database developer tools, both those that integrate into Visual Studio and those that are in the portal, in the Windows Azure portal, and several other spots around the ecosystem. Our background specifically is in database development approaches utilizing DACFX. We are here to talk today about the developer-focused tooling. And so the 6 pieces that I want to cover, or that we're going to cover today, really are our exceptional support for SQL 14, SQL Server 2014, how we've updated the tool stack to leverage those capabilities. En route to that, we're going to talk about SQL Server Declarative and Imperative Toolset in general in Visual Studio, and how those features are exposed in a couple of, actually 3 key scenarios. We're also going to cover some features that have been in a brief hiatus in the product. So we're going to cover data comparison, which was out of the product for a year or so. And then we're also going to cover the Windows Azure tooling integration piece, where we've made some inroads there into exposing SQL Azure Database. And the last couple things are a little bit of miscellany, but we're going to cover the DACFX extensibility story, and how if you run out of flexibility, we're going to be able to open those models up and have some build and deployment contributor pipelines that you can access. And then the acquisition model and SKU support. It sounds a little bit boring, sounds like we're going to be talking about a hyperlink to go to, but actually there's some interesting points to be made there. We have the product is exposed in 3 different versions of Visual Studio, a couple different SKUs, so we'll talk about that as well. So when we talk about SQL Server database tooling, we really try to split it up into 3 bits. That is the developer-focused tooling, the manageability tooling, and the business intelligence tooling. And these really are 3 different things that work in concert with each other. Today's talk is going to be about the developer-focused tooling, specifically that is exposed in Visual Studio, and also known as SQL Server data tools, with no suffix, no business intelligence suffix. We're going to be talking about the T-SQL toolset. The manageability toolset, as contrasted, would be SQL Server Management Studio, classic VS-hosted manageability, performance tuning, and that type of thing. It's Windows Azure Management Portal, which is the SQL extension inside the standard Windows Azure Management Portal, and then SAMP, which is SQL Azure Management Portal, which is the manage link from the standard Azure portal. Business intelligence is SQL Server Data Tools BI, also known in the past as BIDS and Power BI. We won't be covering those things today, but in the session immediately following this one, we'll cover that in quite a bit more depth. Okay, so let's click into the developer tools and framework and how it's exposed in Visual Studio. And that is when we talk about the developer tools, we're really talking about that set of tools you would use to go at T-SQL, but eventually target SQL Server or Windows Azure SQL database. You can work against a live database, you can do offline, you can have source code and projects. And the tooling really sits on top of DACFX, which is the engine that does the heavy lifting for the tool set. And this heavy lifting that it does is it does reverse engineering, it does the comparison engine, it also writes packages, reads packages, and provides all the analysis and algorithms that really make the engine go. So the declarative model that we'll talk about in quite a bit of detail will be covered. That really is DACFX shining through in the tool set. And so the exposure we have for DACFX, besides the tools that are going to be demoed here today, would also be covered under SQL Package, which is a command line tool. We have a managed API over the top of that. And probably one of the most critical things I want to mention today is that DACFX sits under SSMS and the import-export service. It also powers several other data deployment stacks within the Microsoft ecosystem. And with that, it provides a centralized, fully compatible package transport format so that you can ensure that if you're using DACFX, that database is going to be read into and properly interpreted by those other tool streams. Okay, so let's look at SQL Server Developer tooling. We really break this down into three scenarios. One is the connected development scenario, and that is very similar to your classic SSMS style development where you're working on T-SQL directly. That T-SQL is entered into some sort of editor, and then when you execute, you're literally shooting a T-SQL stream right at the server. So the changes are immediate, and this approach is fully supported in our tooling. We have a navigational tree that can connect to servers. You can enumerate objects. You can inspect properties without making any changes. And in our tool set, we also have a table designer, which provides a connected exposure, view and edit of data. You get some validation in IntelliSense. And our data comparison feature that we'll talk about briefly would also be lumped into a connected development. It's great for ad hoc, immediate changes. And we pride ourselves on providing a set of tools where we're not going to prescribe exactly how you use the tools, but we're going to try to match our tool set with how you want to work. And many people work in this direct connected development environment and have for years. It's a very high productivity environment, and it's one we support very well. Very similar to SSMS. So our second main scenario we enable is the project-based development. And this more actively utilizes the power of DACFX and the power of a declarative environment and the power of this design time modeling. So in this approach, you're going to take your database and shred it into bits. And those bits that you shred it into are going to represent the individual objects in your database. And once those are shredded into code files, you're going to be able to treat them as code files. And you're going to be able to utilize an application developer standard of development, which is going to be a check-in, check-out for source code, or you're going to be able to do track changes and that type of thing. So it's going to build, it's going to harness other features inside of Visual Studio to your advantage, like go to definition, find all references. You're going to have one set of source code that can be targeted against multiple different targets. And so as soon as you decouple yourself from that immediate execution that you get with connected development, you really bring a lot of this power to bear. You also have a much richer pre-validation step in that you can try out your changes in a more localized environment. And I don't want that to be strictly taken as on your own machine only. It actually could be on a shared development server that's a database server, but it likely isn't production. It's likely an earlier stage of that. And so we feel very strongly that project-based development is the best place to do serious professional development. It's also great to do migration tasks, which Adam is going to demo today. And in terms of tracking history, version control, or other tools add-ins, it's definitely the way to go. And I didn't mention it, but our project is a standard Visual Studio project. It can be part of a build, multi-developer scenario. It fully supports the ALM stack. You can automate it. So all that stuff is there for you in the project-based development. The last scenario, or the core scenario that we want to talk about, is schema deployment. And schema deployment is something that maybe even if you weren't a developer or doing development-based tasks, you might use this set of tools. And that is, we have a very rich visual schema comparison tool that comes with the tool set. You can automate project publishing, so you could take your project, which actually builds to a DAC pack, so it really should be DAC pack publish. The schema deployment can also generate a script, so if you need to pass off your script to a DBA or somebody else to do a code inspection of that script, if those are the type of control systems you have in your environment. So the schema deployment tool set is actually very, very rich. We talked about SQL Package EXE being a command line utility over the top of DACFX, so you can have a smaller non-VS footprint that you can carry around with you to do deployments. And we have a whole slide dedicated to extensibility, and we have an extremely wide open model for that now. Okay, so we've talked about the different tool sets. We've double-clicked a little bit on the capabilities inside of Visual Studio that we have. Now I want to talk a little bit about the specific support we have for SQL 14. So those three scenarios that I talked about, connected, project, and schema deployment, are all supported with SQL 14 today. This isn't something that's going to come later. We've got it working right now. You can go out and grab a CTP2 copy of SSDT and give it a try. We've updated the templates and all the support for those in-memory OLTP and column store objects that are so popular and getting so much positive, press and feedback are supported in the tool set. Not only that, because I talked a little bit earlier about DACFX being at the base of that tool set, that means that anywhere that DACFX is used, the tool set will also support that. So you have a compatible package for moving through the pipeline. And the other thing that's exciting to have is that we have plans in place for full support for SQL 14 inside of Visual Studio 2012 and 2013, right when SQL 14 releases to manufacturing, or RTMs, goes live. So we're very excited about that. So with that, we'll hand it off to Adam Mahood, and he's going to demo a migration and hackathon development scenario. And I'll hand it over to Adam.
Thanks, Eric. As Eric mentioned, what we're going to be doing today is looking at some development, looking at the first-class support we have in the Visual Studio database tools for SQL Server 2014. Specifically, what we're going to do is take a look at the migration scenario and look at taking an existing SQL Server 2012 database that's running our production application and migrating that out to SQL Server 2014. Now, as we go along, what we're going to do is add support for various in-memory OLTP objects to get the performance gains that you get with the feature set Eric was talking about. So with that, let's go ahead and get started. I'm here, let me do some window cleanup here. So I'm here in Visual Studio 2013 Express for Web. This is a little bit of a preview. These are private preview bits of what's coming down the pike, so a little bit of sneak preview for you guys. I know I'm going to be doing a lot of schema development, but so I could do that first method that Eric talked about, and that's work directly connected against the database. But I want to take advantage of a lot of the isolation and the productivity enhancements and benefits you get with the project system, so that's where I'm going to do most of my work. So in Visual Studio, I'm going to do File, New Project, and create a new SQL Server database project. Now, this one database project type covers or it supports all of the target platforms that SSDT and DACFX support from SQL Server 2005 up to 2014 in Azure. So we're going to be working today on my cardealer.com application. So let me call this cardealer.com. Go ahead and create this directory, and we should be off to the races. And I don't want properties right now. I would rather have Solution Explorer. Let me see if I can get that here. There we go. Okay, so what I want to do, so this is just a stub SQL Server database project. What I want to do is hydrate this guy with an existing definition of my production database. So if I right-click on the project, you can see I have a couple options to get started, or import. I could import from a live database and do basically reverse engineer that database into source code. I could import from a handful of T-SQL declarative script files. But what I'm going to use a DAC pack that I've already created from my production database. And what a DAC pack is Eric touched on it a little bit, but it's really the fundamental common schema transport format across the SQL Server client tooling. It represents a blueprint of your database schema, and that's the best way to think about it. So if I go browse, I'm going to pick this cardealer.com DAC pack. And again, you can extract a DAC pack from a live database containing the schema, just the schema, or the schema and the data. And you can do that from a variety of tools like SSMS in SQL Server Object Explorer right here in SSDT. So you have a lot of options of how to get one of these DAC packs from an existing database. So I'm going to import database settings, leave the rest of the defaults in place, and go ahead and kick this off. And what this is doing is basically cracking open that DAC pack, inspecting that model, and building a full fidelity logical database model from that schema blueprint. And then taking that model and shredding it down into individual T-SQL source code files representing all of my objects. So if I go over here to Solution Explorer, expand, you can see I have DBO folder for my schema, and then all folders for tables, views, stored procedures. So if I just click on one of my stored procedures, delete car, I get a source code file just like I would for any other project, and I'm working against the declarative, in a declarative manner, against the definition or create statement for my object. Okay, so now this is a source code representation of my production cardealer.com database. I want to do a couple more setup things before we get into the meat of the development here. So if I go to Project Properties, I want to change the target platform to SQL 14. Now, this notion of target platform is really powerful. This setting basically tells DACFX against which platform to do its robust and rich validation. And so that it's going to look at that platform and say, okay, I know I'm going to target SQL Server 2014. Let's validate the contents of your project and your logical schema model against the requirements of that platform. So by changing this to SQL 14, I'm now getting immediate real-time validation against the SQL 14 platform requirements. So that's goodness. The other thing I want to do is change my default debug database. Now, one of the main benefits of working in the project system is that you get this rich, isolated debug development loop like you would for a C# application. You make a change in the project system, you can deploy it out to your local database or your local instance and do real-time validation. By default, you can see here we set you up with LocalDB, which is a lightweight file-backed version, basically SQL Express. But I'm going to retarget a live database since I don't have a version of LocalDB that supports SQL 14 yet, so I'm going to change this to my local SQL 14 instance. And we'll just call this my cardealer.com debug database. Let me save that. Okay, so we've done a little bit of setup. The last thing I want to do before we really get cooking is to make a baseline of this project. Now, what Eric and I would normally do, if both of us were working on this project together, we'd check this project into source code control now, so we could, make real-time edits, get change tracking, and leverage all the benefits of team development. But since I don't have source code control right now, I want to use DAC pack snapshots instead. So if I come up here to the project and click Snapshot Project, what this is going to do is basically compile another DAC pack for me and automatically add it to my project. And this DAC pack contains the blueprint of the schema definition of my project at this point in time. So I now have a single file representation of my baseline cardealer.com database with this target platform set to SQL Server 2014. So with that in mind, I think I'm ready to just do my first debug deployment out to my debug database and get up and running on SQL 14. So just like I would in a C# app, I can just do an F5 or start debugging. So let me go ahead and click this. And this is going to connect to my local SQL 14 instance. And if you look at the output, it's going to first create my database since it doesn't exist yet, and then deploy each of the objects that's defined in my project. And it looks like everything worked quite well.
You want to zoom in on that maybe?
I would if I knew how very quickly. Unfortunately, I don't have to zoom in right now.
Okay.
But I will zoom in when I get a chance. Let me go over to SQL Server Object Explorer. And this window is really your home for, now if I can get my clicker here, database development activities inside Visual Studio. And what Eric talked about, that first column, really the connected development experiences, SQL Server Object Explorer is where you're going to find launch points for most of those tasks. So creating or dropping databases, initiating a schema or data comparison, anything along those lines. So if I refresh my databases node, here my cardealer.com debug database, Looks like all my tables and views made it okay. Let's check that sprock that I looked at in the project. Let me right-click View Code. And again, the exact same definition as I started with in the project. Looks like my deployment did go as planned. Let me get myself some more screen real estate. So as we go along, I said we're going to be adding support for in-memory OLTP to get performance gains. To measure that, we need to take an initial benchmark. So to do that, I'm going to come up and right-click on my database and click New Query. And this launches me into the familiar T-SQL editor that you'll find in SSMS. Again, it's that familiar way of working that we've brought into Visual Studio. Now I have a script here already ready, so you don't have to watch me type today. And now I will zoom in a bit, perhaps a bit too much. Some overzealous zooming there. Basically what this is going to do is our crude benchmarking tool. We're going to go through and in this dbo.value table, we're just going to go through a while loop and insert 100,000 rows. And we're going to see how long that takes. And value is just a simple table with a primary key int column and an nvarchar that we're going to stick this value in 100,000 times. So nothing fancy, but just a nice way of getting a baseline benchmark. So I'm going to come up here and execute this guy. Oh, I did that last time too, highlighted that value. Let's actually run the entire query. So as this churns away, one thing to keep in mind is that I'm running actually on a Windows Azure virtual machine right now. So this whole thing is being, the whole SQL engine is hosted up in the cloud. So, you know, whatever latencies we get, we're up in the cloud. So we'll see what we end up with here. Okay, so it looks like our SQL table with clustered index, I'll copy that out into another notepad. Looks like our baseline is about 9.5 seconds. So it's a pretty good baseline for 100,000 rows. But we want to get some perf gains. So to do that, I'm going to go back to project-based development and add a hackathon table. So what I'm going to do is what Eric and I like to refer to as hackathonizing this table and taking this values table from a standard T-SQL table to an in-memory OLTP table. If I want to go up and add, to show you some of the templates that we've added for these new SQL 14 objects, let me go to New Item. And you'll see, type in memory. And you see we have memory optimized file groups, table, this combo table file group here, which is really handy. This pops you into our new table designer, which has two ways of working, either a graphical user interface, a nice columns grid if you prefer a UI approach, or if you're just a T-SQL guy and you like working against T-SQL script, you have that method of working down here as well. I'm going to delete this guy because I already have a script prepared. So let me view code on our existing value table. Oh, I want to comment out this guy. Grab my script. Okay, let me zoom in a bit. So let's take a look at this. So a couple things to point out. First, you can see we're adding our hackathon file group to the project. And before you can add any hackathon objects to your database, you have to have a file group that contains memory optimized data as the home for all of your in-memory OLTP data. You can see we're using SQL command syntax, which is another great productivity booster we give you in the project so that you can define variables and use them throughout your project for targeting different environments or using different security scenarios. Database name is one of the built-in variables that we give you, and we use that, pick that up by default here. So let's go down to the table definition. You can see with these two side by side, there really isn't a lot of differences between the two definitions. In the new table, you'll see we've gone from a primary key clustered index to a non-clustered hash index. Hash indexes are the required index type on all hackathon tables, so we stick that on there. And hash indexes have this thing called a bucket count, which really basically is how much memory is allocated for the data in this memory optimized table. The guidance from the hackathon folks is that the value for your bucket count should be about 1 to 2 times the expected number of unique values you anticipate in this index. So since I know we're working about 100,000, I'm going to stick it up about 500,000 just to give a little headroom. The other two things to point out here are this memory optimized flag, which is the high-level bit saying, hey, I'm a hackathon table, and then this durability. So durability defines what you want persisted on disk across SQL Server sessions or failures. In this case, I don't need the data in this table persisted, so I'm going to only persist the schema on disk. Okay, so we've got our table definition modified. I want to just do another quick F5 deployment out to my debug database, so I'm going to kick that off. and what you'll see as we go down in the output window that we're not starting from scratch. We're not rebuilding that database. We're not deploying every object every time. Under the covers, DACFX knows that that debug database already exists. So it's doing a targeted comparison to understand the differences between your project and the database, and then crafting an incremental deployment script of the minimal set of T-SQL necessary to update the target. And so you can see we added the file group and we rebuilt the table. Let me double click on this guy to get to the actual script that was executed. So you see a couple things. Here we're just adding, minimize that. We're just adding the file group and file, and it picks up that database name command variable. And then we're rebuilding the dbo.value table. And you may say, hey, wait a minute, why are we rebuilding a table here? I only changed a few properties. Well, DACFX understands that hackathon tables don't yet support alter syntax. So under the covers, it knows that it needs to do the table drop and recreate in data motion around that syntax element. And if you look at the syntax here, it's not particularly clean. So imagine if you had to write this for all of your tables. You know, this is really the power of DACFX here, is crafting this incremental deployment script so you don't have to do it by hand. So let me close that out. Go back over to SQL Server Object Explorer. Now there are no new objects aside from that file group. So I can really just go back to my query window. And you may say, okay, what all do we have to change in this benchmarking script to work with the hackathon table? And the answer is just the comment. Think about this from an application access perspective. I don't have to change anything in this benchmarking script to work with this hackathon table. If this is my data tier of an application, I don't need to do anything fancy to get this existing application to be able to start leveraging the power of in-memory OLTP. So let me just go ahead and execute this guy again. Let's hope the demo gods are on our side and get us a good perf gain here. And it looks like we actually have, just by doing a few clicks in the project system, a few T-SQL changes, we have about a 10-fold reduction in our while loop. So getting some awesome perf gains already. However, we are not done yet. The other main object that is part of the in-memory OLTP feature set is natively compiled stored procedures. And what this object allows you to do is basically craft regular T-SQL stored procedures that get compiled down into native machine code by the SQL Server engine at runtime. And that, again, gives you awesome raw performance benefits. So I'm going to come up here, go back to my templates, add a new item, do a search for natively compiled. You can see there's that handy template again. We'll call it insert value. And before you can see that, I'm going to pop in my final script. And as you see, the meat of this stored procedure here is exactly what was in our benchmarking script. So what we're doing is inside a while loop, inside this proc, we're inserting 100,000 rows or whatever value you pass in as the input parameter, and executing that, inserting those rows into the value table. Now, a couple other hackathon-specific syntax elements I want to point out. With native compilation, again, this is your high-level bit saying, hey, I'm a hackathon procedure, treat me with the appropriate kid gloves. Schema binding and executing as owner. All natively compiled stored procedures have to be schema bound and executed as the database owner. And then this last begin atomic with says, tells the engine to treat the rest of this proc body as a transaction. So one thing before we deploy this out, I want to point out some of the great first-class support we have for T-SQL inside the project system. So if I right-click on the identifier, you'll see that we have some of the things that most app developers have taken for granted, and that's things like refactor rename, which will do a logical find and replace inside your project. If I go down to the value table, I can do go to definition, which is going to take me right to that table definition. The inverse, I can find all references. Again, I don't have that big of a project, but you can see it finds all the references to that value table, including the procedure. So let me go back there. And I'm about ready, I think, to do my final debug deployment. So let's kick this off. Looks like it worked. So let me go over to get some real estate here, refresh my stored procedures folder, and here we see this new insert value proc. Now, instead of crafting some T-SQL, I'm going to leverage this handy feature we have in SQL Server Object Explorer, one of those ad hoc tools, to directly execute the procedure. So you get a template with all of the variables that you need to specify. I'm going to pass in 100,000 because that's the number of rows we're going to do. And this is going to create a little execution harness, wire up my procedure, and kick it off. So let's see what our final perf gains are. And the drama. And looks like we're doing pretty well. Let me copy this out so you can get a better look. And it looks like we've gone from just about 10 seconds down to sub 1 second, and now we're down to 78 milliseconds by wrapping that while loop inside a natively compiled stored procedure. And again, it is a bit of a crude benchmark, but it's really valuable just to show you, along with the first class support you get in the project system, the perf gains that you get with these objects. So one last thing to look at sort of how far we've come, I'm going to use schema comparison to look at the current state of my project and compare it to the baseline DAC pack that we started with. So let me right click on the project, do a schema compare. And because I launched from the project, it automatically sets that up as my source context. And for my target, I want to pick that baseline DAC pack I created. So in schema compare, you can compare either a live database, a database project, or a DAC pack to any one of the other three. And so I'm going to use the project to DAC pack combination here. And we're kicking off a comparison. Again, DACFX can craft the same logical model from any one of those source representations. So what should we see here? It looks like we have our value table is changed. That's expected. We made it a hekaton table. We hekatonized it. We added that insert value proc, which is that natively compiled stored procedure. And there's our hekaton file group that stores all of our effectively hekaton data. Now I'm sort of done with my debug loop. And what I can do is now break out of that debug loop and publish this project out to my test or UAT. This is what I would do at the end of a development cycle and push that out to my test environment. So if I go to my database, right click and select publish, here I just want to pass in my credentials, actually server name. And we're going to call this test. And we're going to publish away. And that sort of wraps up my piece of the demo as we deploy out to our test environment. What we've basically done is taken a live SQL Server 2012 database, migrated that out to SQL 14. And along the way, we've used the great support you get for SQL 14 in the database project system to add support for Hekaton and look at the perf gains you get with in-memory OLTP. Now I'll kick it back over to Eric for some slides.
All right. Thanks, Adam. A little bit of a change of direction, but great demo and great performance improvement there, and we took a peek at publish at the end. So data comparison was out of the product for about a year. When we replaced the previous set of tools, one of the things that we was missing was data comparison. And data comparison is a great tool for selective comparisons of small and medium-sized data sets. And it not only will compare those data sets, but will also make the requisite changes to bring the compared data set up to the same sort of stamp. It'll basically drive differences both directions, and you can end up with two identical data sets. So it supports for all data types, 2005 and up, and the entire product stream that we've talked about has this same server support matrix. One of the things that we talk about data comparison, sort of the data comparison is very good for what it's for and not so good at what it's not for. And that's a little bit hard to say, but if this is not a heavy-duty data curation or transformation tool, it is not something that is automatable from the outside. But what it's good for is that ad hoc, small and medium-sized data sets. It works for what you want to get done. A lot of another question we get frequently around data comparison is data generation. And data generation, unfortunately, is not planned currently. And to automate data generation for use with database unit testing, you'd have to use third-party tools for that. Okay, so this gives you a quick take a look at what a data comparison UI might look like in the product, where you have two different same schema databases. You can pick a selection of tables, and you get a very good graphical representation, highly accurate. It shows what's identical, what's different on one side, the other side, and you can actually script out the changes necessary to make those and execute those separately. Okay, so let's take another left turn here, and let's talk a little bit about integration with Windows Azure Tools SDK. So there's a new Windows Azure node in Server Explorer, and we talked a little about SQL Server Object Explorer. There's another window in Visual Studio called Server Explorer, and that's where you have a server or historically have had a server-based view of things. The Windows Azure node now supports SQL Database, and this gives you a subscription level view over your SQL Azure assets rather than in SQL Server Object Explorer, that is a server-specific view, or even in data connections, if you go back historically back farther, data connections is a database-specific view or a connections view. So this exposure of SQL Azure in the Windows Azure node is fundamentally a navigational aid and a discovery aid. The development tools that you've seen here today in SQL Server Object Explorer can be linked into from this exposure in the tool set. You can also link up to the portal experience that you would use for your Azure assets. Let's see if I missed anything. No, that's great. And in 2013, we support website databases and mobile services. And then if you get the full Windows Azure SDK, additional services will be brought online. And right now, our support for SQL Azure Database is in Visual Studio 2013. So let's take a look at a quick demo, another one from Adam, on how to set up your subscription, how to do some simple navigation, and go from there.
Let's do it. So what I'm going to do is basically show you how to get your Visual Studio 2013 Windows Azure node hooked up to your Windows Azure subscriptions so you can use that great functionality that's been brought down into VS. So here I'm at the home page for the Windows Azure Standard Management Portal. You can see I have a broad view over all of my different assets across the different services and my different subscriptions. If you go to the databases extension, again, this is just a top-level view of all of my databases across all of my different accounts and subscriptions. So if I go back to Visual Studio 2013, I'm here in Server Explorer this time. Note the context switch from SQL Server Object Explorer to Server Explorer. I have this Windows Azure node with all of the different supported services listed under the side. So if what I want to do is basically connect Visual Studio with my subscription in the cloud. And we do that with certificates. And so I want to get started here by right-clicking on the Windows Azure node and select Manage Subscriptions. Go over to Certificates and Import. And if I click this download subscription file, what this would have me do is go up to the portal and save a file locally. And that process, saving that file, would also upload that same certificate up to the management portal. I already have a cert downloaded locally, which is what I'm going to use now. But it's just a couple clicks, and you can make that link in a few seconds. So let me go browse to my desktop, grab my published settings file, and import that. And you can see it grabbed both of my subscriptions from my account. And if I go back to the portal, in fact, go down to the settings extension, management certificates, you'll see that it automatically uploaded that certificate without me having to do any of the SSL or cert magic. Without having to do any of that, it automatically set me up for success. So let me go back to VS, close that. And now a lot of that, if you're an app admin, you spend a lot of time in the Azure Management Portal doing provisioning or management tasks. With this Windows Azure node functionality, you can now do a lot of that inside Visual Studio to help you bridge that gap. And so if I navigate, you can see some of my cloud services. You can actually see the virtual machine that I'm currently running on. If these will, looks like I need to feed it some coffee. It's a bit late in the day here. There we go. So there's my Admahood demo. So it's sort of a bit recursive here, a bit meta. My different endpoints. Here's my cardealer.com website. Should pop up here. And if I do something like click on the virtual machine, I have some powerful gestures and launch points. So I can connect to RDP directly from VS. I can restart and shut down the VM. The website, if I launch in and view the settings, you can see that in my connection string, I have a linked database. And that's not something that you could, it's not a link or a connection that you previously could have understood without going to the management portal. But the real sweet spot here is what we're here to talk about is SQL databases. So if I expand this, you're going to see that same view that I had in the portal, which is all of my databases, regardless of server, in all of my subscriptions. So here you can see the database that's powering my mobile service, my website. If I view properties of this guy, you'll see that it's in the East US data center, this particular server, and this subscription. So a lot of great information here. What you can do now, if you want to get into a bit more deeper database development like we've been looking at, we have a launch point for that from this node. So if I right-click on cardealer.com web, I can open in SQL Server Object Explorer. Now the first thing it's going to say is, hey, you can't access this database yet because you don't have any firewall rules. By default, all servers are created with all the firewall totally blocked down. and it detects that, and it's allowing me to quickly add a new firewall rule for this IP. So let me do that. Type in my credentials and connect. And now in SQL Server Object Explorer, it's going to automatically populate a connection directly to that database without me having to do any of the wiring up. So you can see I have my cardular.com web database. And if I want to do some more development, I'm off to the races here. I can create a new project or do some ad hoc schema or data comparison like a lot of the other scenarios we've already taken a look at. So that's really a quick look at how you can get up and running with this powerful new Windows Azure Node functionality in Visual Studio 2013. And as Eric mentioned, look for more to come in this space as we continue to grow on some of these Windows Azure SQL database scenarios inside Visual Studio.
Great.
Eric?
Great stuff, Adam. Adam, when he went to publish at the end of the first demo, he talked about a couple of the different options that were available. We didn't show those directly, but there's about, I think, somewhere between 70 and 85 different deployment options that you can do just built into the project system, built into the DACFX deployment pipeline. Those are what you get out of the box.
Yep.
At some point along our development cycle, we decided that adding one more option and one more permutation of those things was getting pretty difficult, and it honestly wasn't meeting every customer's need. And so what we've really put a lot of effort into is opening up our extensibility pipeline, both the build and deployment contributor extensibility pipeline, so that you can programmatically extend any of those events. You can trigger those off of particular things within those pipelines. And even particularly near and dear to my heart is that we've opened up the Schema Model API. And the Schema Model API enables you to inspect, write, or alter one of those database logical models that we've been talking about for the last 40 minutes or so. And that is any of those models that get created, or if you want to create one yourself, you can inspect and extend those. And we have some extremely interesting tooling scenarios for that, where we've partnered with the LightSwitch folks in terms of their design time experiences in Visual Studio, writing to a dynamic model as their customers then create LightSwitch apps. So very, very, very powerful stuff. I will put a warning in, not light duty,
Not for the faint of heart.
not for the faint of heart, and can be exceedingly dangerous. We all know that database development has a bit of an edge to it, and there's not a lot of undo on some of these things. So you're going to have to work pretty hard to make this fit for you. But if you have a business need, you have a particular scenario that you need to enable, this is that opening for that. And one thing I wanted to mention for the extensibility is that went live in June of 2013 this year. So if you haven't grabbed a refresh set of bits, that went live in June, and that's for 2010 and 2012. But in 2013, it's like that out of the box. Okay, let's talk a little bit about acquisition and SKU support. A little bit of a complex topic. It really shouldn't be, but I think we've arrived at a place where we have a really clean model from here going forward. If you wind the clock back in 2010, we were an add-in because we weren't part of the Visual Studio baseline. In 2012, we were part of the Visual Studio baseline. All the tools you've seen here today, minus a couple of the new ones, were there. But you had to install an add-in from the web in order to get automatic updates. With 2013, all the tools are there out of the box. They're in all the Express queues, and the integrated in-shell notification and delivery is the same exact pipeline as Visual Studio. It's a very clean story, and one we're actually really proud of. And the reason that I've included this future Visual Studio column is not because there's any changes there, it's because there are no changes. We feel like we're at an end point in terms of a tools acquisition, a versioning story, and a platform support story. For example, one of the things that we're most excited about is really delivering SQL Server tooling for SQL 14 the day it ships. And by delivering it, we mean in Visual Studio, you'll get a prompt that says, download the latest and greatest DACFX and SSDT, hit a couple of buttons, and you're good to go, targeting SQL 14 that day. If you read in the pay row here, we do have 3 features that are only available in the Pro Plus SKUs. And that is SQL CLR authoring, SQL debugging, and database unit test authoring. And those really aren't a function of anything else besides the dependencies upon which those rely are in the Pro SKUs only. Updates, we talked about in-shell notification for 2010 and 2012, but you do have to install SSDT at least once from the web. From there on, you're going forward. And in 2013, it's built in. Okay, so platform support. In Visual Studio 2013, full database tool set available in box in all the SKUs. We talked about the 3 features that were in the pay SKU. If there's one thing that I want people to take away from this discussion is that the DACFX transport format and the project format in Visual Studio are 100% compatible from 2010, 2012, and 2013. If you make an investment in these technologies and these formats, we have made a pledge to keep those compatible going forward. So if you have a mixed shop where you've got developers on one version of Visual Studio, maybe an Express SKU on this machine, 2010 pay on another machine, those artifacts in the multi-developer scenario are going to work for you. It's going to work actually seamlessly. It works extremely well. Okay, so what have we covered? We covered the tool set on the whole, the declarative and imperative pipeline, schema comparison, the deployment stack. We've talked a lot about SQL 14, did a fantastic performance demo where we wove through all the different capabilities of the product. We've really announced data comparison again. It's been out for about 5 months now, 6 months. We've taken a look at how we've opened up some discoverability and centralization of your Azure assets under this Windows Azure node for SQL database. And I think this isn't as deep a talk as we've sometimes done around deployment and extensibility, but let me tell you, your flexibility here is incredible. You can pretty much do anything you want. And then acquisition and SKU support, an area of confusion in the past. We want to make sure that's 100% clear and the messages there are 100% understood, and that is SQL Server platform support in the tool set you want to use, how you want to use it. So with that, thank you on behalf of myself and Adam. Thanks for your time. We have some additional resources here. We've got an active blog. Like I said earlier, you can go out and grab CTP2 today. You can play with it. SQL Server is available out there. And I think that'll pretty much wrap it up for us. And we have about a 15-minute break here, and then we'll be talking about, I believe, SSDT business intelligence. Well, thank you very much.
Thanks, guys.
Hello, my name is Greg Leake, and I'm a product manager at Microsoft on the SQL Server team, and I'm joined by my colleague, Lance Delano, who is a program manager lead also on the SQL Server team. And today we're going to, in this last session of the day, really have a logical tie-in to the session that you just saw, which was Eric and Adam talking about SQL Server data tools and the core SQL tools that have been integrated into Visual Studio. And what we're going to do in this session is transition from those kind of T-SQL tooling experience for SQL and SQL 14 over to the business intelligence tools. And that's Lance's forte, is all about the BI tools that we have integrated not only into Visual Studio, but now in CTP release, I believe, available for 2014.
That's right. Very good. All right, so let's get started. Let's talk a little bit about SSDT BI, as it is called. And to kind of kick things off, a little bit of my background. I actually started, one of the things I did a while back was actually work on SSDT core, which you heard about in the first hour, and I've transitioned on to work on SSDT BI, and I'm a lead program manager for that. And SSDT BI is quite interesting, and I've been in the industry for a while, as you can kind of see there. I've done a lot of developer tools for a long time. So today, if you are a BI developer or want to be a BI developer, this is the session for you. This is an overview for SSDT BI. We're not going to go into great detail on how to actually make these solutions work in great detail, but we will give you the context for them and how you should think about them at sort of the high level, and we'll dip into a demo and show you a little bit about how it works and why it's interesting. You shouldn't need anything in order to kind of get started. So this just kind of relax and kind of enjoy understanding what's going to go on. All right, so first we're going to talk a little bit about the overall context for Microsoft's BI offerings. We have a personal sort of BI offering and a team BI offering and a corporate BI offering. And it's in the context of that you need to be able to understand SSDT BI. So, and then we'll talk a little bit about, we'll actually go into some details about how you get it and what those versions of SSDT BI will actually support. And we'll do a demo, and then we'll do some takeaways.
Sounds great.
Very good. Okay, so as I mentioned, Microsoft has 3 sort of BI offerings or stories that we like to enable for our customers. And the first one is what we like to call personal BI, and that's basically BI content that is created by the user. It exists in a document typically, and it stays, on my machine. It's created by me and it's for me. Maybe I'm exploring or trying to understand the details behind some numbers. But business intelligence can mean a lot of things. But if I'm trying to explore and understand and document, that's what kind of personal BI is about. I might give it to my boss or something, yeah.
So when you say document, I think my guess is you primarily mean an Excel workbook that a business user might be exploring the data in to make discoveries, kind of ad hoc discoveries around the data. Is that right?
Exactly, or a single report. So exactly, it sits, as we show down here at the bottom, it sits in Excel, and Excel has 3 add-ins. It has Power Pivot, it has Power View, and there's a new thing that just has kind of come along called Power Query. But the container for all of those things is Excel. So I put it into an Excel document, and I might just use it, or I might give it to my boss.
You might send it an email or what have you, but it's still kind of just a solitary document at
Right,
that point.
yeah, it's just intended just for me.
Right.
The second sort of BI context is what we call team BI. And it's the same 3 things. It's Power Pivot, it's Power View, and it's Power Query, but in a sharing kind of a mode. Now I'm going to put it up on a SharePoint, or I might put it up on Power BI, and I want the whole world to see it, right? And so, being able to get previews of what's actually in the document without actually downloading it, so I can get a web preview without actually editing the document, for instance. That's what Team BI is about.
Okay, so when we say the whole world, that's the whole world or whoever you restrict access to.
Yeah, my team
your
world.
team, right.
Yeah,
your
yeah,
role-based, it integrates with AD security as SharePoint does, et cetera.
Exactly.
But at least you're in an environment now where it's moved beyond the stage of just a personal workbook, and you can actually get it up to your team members, share it with your boss, your CFO, or whoever you may want to share it with.
Exactly, exactly. And so things like source code control, they're being able to check things in and out actually start to get enabled in those worlds.
Okay.
Right. All right. And then the third context is what we like to call corporate BI. And corporate BI this is a little bit of a different situation. In this world, typically there's an IT manager or there's a developer, an IT person or a developer that's gone to the trouble of bulletproofing this data. And now it really is for the whole corporation, it really is for the whole world, but it has to be more resilient, right? So for instance, if I create an ad hoc view on top of this thing, it can't fail.
Right. So you don't necessarily want team members kind of tweaking it and making changes at this point. This is kind of the truth that you want to publish out to the corporation.
Yes, and it's also the case that I might have, if I'm just doing personal BI, I'll worry a little bit about this particular view of the data. But when I'm talking about corporate BI, I have to think about all the different angles that people might want to look at it. And so I have to bulletproof it. So I have to be very careful about the data that flows into it, that there are no blanks, and that I've thought about the various error conditions, right? That the data gets refreshed on a regular cadence, for instance.
Okay.
And then the final one that we find a lot of corporations really care a lot about is that if it's a corporate solution, let's say it's for sales, I want the East region to be able to see their numbers, but not see West or some of these other.
Right.
So I put security and I put row level security on this data, right? And so I'm limiting who can actually get at it.
So I think you gave it away there when you said row level security. Obviously, in this model, we're tied back to a corporate SQL Server database.
Well, yeah, in this case, eventually it goes to a SQL Server database, but in this case, it gets rolled into SSAS, SQL Server Analysis
Service. Okay.
And even there, we have row-based security so that we can kind of limit who can actually get at it.
Okay.
In fact, the Microsoft sales team actually uses this in this very, very way. So they'll publish a Power Pivot workbook, but it's backed by an SSAS server, tabular model, and the East region can look, or the region, the Microsoft regions can look at their respective areas and not see the other areas.
Makes sense.
Yeah, so that's what it kind of means to kind of move it to the corporate world. It's bulletproofed. You have to do things like check it into source code control and stuff like that, which is very different from what you have from a personal kind of
Right,
situation.
it's not the mode where you're doing the ad hoc, the personal BI mode where you're really kind of doing the exploratory mode. Right?
Exactly.
Okay.
All right, so what are some of the characteristics of that make a difference between corporate BI and some of the others? So one of them we talked briefly about, which is there's some of them on here is security, but let's talk first about scalability. Sometimes these models get into terabyte-sized models, and that's not something I'm typically going to do on my desktop just for me. So I need to partition the data. I need to say I want the first 12 months here and the previous 12 months there, and I'll put them on different nodes, and I'll kind of put them out there. Manageability, I have to be able to manage it remotely, and I have to be able to refresh it remotely so that no people are actually involved. And there's a variety of means for doing that. There's SQL Server Integration Services packages, there's PowerShell, and there's a programming model called AMO that you can use to get at it. And security, we talked briefly about that. And then development, it's super important when you're developing a corporate solution that you have things like source code control, you have team kind of development sort of experiences.
Modes to restrict and put appropriate controls in place.
Exactly. So all of this means basically that the corporate solution lives in Visual Studio and SSMS, but that's in the Visual Studio solution is what we call SSDT BI.
Okay. So that, as a wrapper, is the business intelligence edition of the SQL Server data tools.
Exactly. All right. So a little bit more about SSDT BI. It was previously known as BIDS. So sometimes in the literature you'll see, what's happened to BIDS, or where is BIDS, or where can I find BIDS?
Correct me if I'm wrong. BIDS was Business Intelligence Development Studio.
It was BI Developer Studio.
Right.
Exactly.
But no longer.
But no longer.
Okay.
That's right. And as I mentioned, there's three project types that are in there. There's analysis services, there's reporting services, and there's integration services. Those are the three project types that are there. It's now a web download. It used to ship in the box. What was BIDS used to actually ship in the box. Now you just get it as a download, and you can download the most current version at any point in time. You can just go get it. And this is a very super important point. As we enabled our personal and team BI story, we started to align with Office. As we ship in Excel, that means our cadence will match the Office schedules.
Right.
Right? Because we can't have Excel and what you can do in Excel be out of sync with what you can do.
So I believe that means the practical implication of you're getting and using these tools is that when there's a major new release of Office or BI functionality with Office, you could expect to have to go download a new release of the BI tools to get that new functionality.
Yes.
And that's important in the context of the last module we covered, where Eric spent some time talking about the cadence of the SQL Server data tools, the T-SQL core tooling that really is integrated in the Visual Studio cadence. Instead of the BI Office cadence. So It's a slightly different acquisition model, but there's some good news here. Both sets of tools are free. So if you have Visual Studio, they'll integrate with Visual Studio Pro and above. If you don't have Visual Studio, you have a free download that you can get. And so in either case, they're free tools for all developers, whether you're BI or core or both, to get and use.
Yeah.
Great.
Exactly. And so when you hear of SQL Server, for instance, doing a major release, it's not always that we'll have big BI updates in that release. We'll have the big major functionality updates will come along with Office.
Okay. That's a good clarification.
Well,
point.
all of what you said is true. It's just that the big features, people expect big features when there's a release of, say, SQL Server.
Right.
But they should really be looking for the big Office releases because
for
that's
the BI, for the new BI features.
Because that's
Yes.
what we'll line up with.
Whereas with SQL Server, you would expect to see the major features like the in-memory OLTP, the mission-critical enhancements, the hybrid cloud enhancements that we've covered in earlier modules today.
Yeah.
Great.
Very good. All right. And then the final point is that almost everybody that works in the BI sort of developer space with Microsoft tools use third-party tools. And there's a number of them that are out there. There's BIDS Helper, there's DAX Studio, but everybody uses these open source tools that are designed to work with our project types and templates.
Okay.
So if you are getting into this space, you should understand everybody uses them. So, and we try to work with that community. All right. Currently today, we have, and what I'm going to be using to demo today is the Visual Studio 2012-based version of SSDT. And you can see there that it supports SSAS versions that are 2012 or lower, and SSRS projects of SQL 2012 or lower. And then SSIS only targets SQL 2012. And that has to do with the way they've kind of been built architecturally in the past. That's going to be changing in 2013 and forward, although you'll see here in 2013 we'll support SQL Server 2014 and lower for SSAS and SSRS. SSIS will only target SQL 2014, but going forward it will be able to target lower projects. And they made some changes in this last release. Previously they'd been targeting the binary version, and now they're going to be supporting a compatibility level in their engine like we do in SSAS and SSRS.
Okay, that makes sense. And so I think also, if you notice on that slide, it was in smaller print. You could today go up and get the pre-release of SSDT BI for SQL 2014.
That's correct.
There is a free download available that's essentially a CTP, a Community Technology Preview, that supports SQL 2014.
And it is 2012 based. However, it will go away when we actually release
Visual Studio 2012 based.
It is Visual Studio 2012 based.
But it'll become Visual Studio 2013 based with the release of SQL 2014.
That's right. And
we got our years all going on here.
Yeah, that's right. That's right. Anyway, so but the version that is Visual Studio 2012 based will be retired when we actually release SQL Server 2012.
And then for the standalone mode, you would get the Visual Studio 2013 integrated shell as a standalone shell for the tool.
That's right. You could either, depending on whether you wanted, if your Visual Studio environment, if the standard in your work environment was 2012, you could get Visual 2012. You wouldn't be able to go target SQL Server 2014.
Right. You need the VS 2013 shell for that.
Right.
Okay.
And then 2013 will target everything below.
Great.
With the caveat with respect to SSIS.
Great. So I think we got all the bases covered there. all the versions of Visual Studio and all the versions of SQL Server well covered.
Very good. Okay, with that, let's kind of go to a demo and kind of show a few things here.
Cool. Let's take a look.
And we're going to start with Excel. And this is just simply to illustrate the functionality that we find in what we see in the personal side of the story. And then we'll contrast that with what you get on the corporate side.
Okay.
So here I have Excel, and I see I have Power Pivot here. It's been enabled, and I say I want to manage, meaning I want to work with a Power Pivot model. Now, the important thing to understand here, as we ship Excel, inside of Excel, we actually ship the same analysis services engine as part of Excel, except it's kind of stripped down a little bit. And it's the same version that we ship for the version that we ship that has partitioning and everything else. It's the same core engine, so that's why you can kind of transfer these models.
Okay.
So if I go ahead and say I want to bring in some data from, say, SQL Server, I want to import it, and let's say
so you're going against a live SQL Server database.
Yep, and this one's one that's been prettied up a little bit, so it has nice SSAS kinds of things like dimensions and tables.
Okay.
But it is just simply a relational database. And I'm going to go over here and I'm going to pull in fact internet sales, one table. And then I'm going to come over here and I'm going to select all of the related tables. And what that does is it looks at that fact internet sales and it looks out at all of the tables that are related to it and it selects
Via
them.
the foreign key relationships as defined in SQL Server?
Exactly.
Okay.
And I'll bring that in very quickly. That'll just take a couple of seconds. Okay. Now we'll close that and we'll take a look around here at what you actually have. So you'll see the inside, let me just, for those who've never seen it, here's Excel over here and here's Power Pivot, which is the window that was launched from within Excel. And in here I can do things like, well, first of all, let me just kind of very quickly.
I'll give you the tabular view here.
Yeah, I'm going to give you the diagram view of this. So this is what I said earlier, fact internet sales, and it went out and looked at all the foreign key relationships that are related to it. So that I come over here and I say select fact internet sales, I can do things like, and I'm just going to very quickly do this, create a, so we'll say, so I want product. total product cost plus, say, freight. And I'll just...
So some aggregation functions. You're putting functions in.
Yeah, this is creating what's called a calculated column. And this basically adds a storage row. It extends the table. And this gets actually stored in the data.
Okay.
Okay. And now I'm going to come over here very quickly. And I want to find total product sales amount. Here it is. And I come in here, write a quick little formula, and I'll say sum of sales colon equals, and I'm going to say, whoops, I want to say sum, and I want, this is fact internet sales, and I want to pull in sales amount. Great.
All right.
So what this has done is create something that we previously have called a measure. So I have two things in here. I have a measure and I have a calculated column. So now I'm going to close this and come back to, whoops, I want to do one other thing really quick. I want to insert a pivot table into Excel. And what this has done, you can see here are the tables that exist in my model. This is coming straight from Power Pivot, and it's stored with the Excel file.
Okay.
And so now what I can do is I can come over here and I can say, okay, I want to say, remember fact internet sales, and you'll recall that we created a thing called sum of sale right there. And let's say that I bring in, say, dim product, and let's go look at, say, all of the colors. And these are the colors of the various products. Pretty simple little pivot table, right?
Some simple. We're not really business analysts over here. We're more developer types, but I get the gist. You want to look at sales by color, apparently.
Exactly. So you can imagine I can build out a very complex pivot table. Okay. So keep that in mind. So this is what I've done. But remember, sitting in Excel is the data. It's sitting right here.
Okay.
All right. Okay. So we're going to close this guy because we don't need it anymore. And now we're going to go to Visual Studio. And we're right here. Oops, I need to start over here.
No problem.
I want to close this solution. No.
So
okay.
now we're in 2012 here.
We're in 2012.
But shortly at the release of SQL 2014, you'll be able to use these same tools within Visual Studio 2013.
Yeah, exactly. Okay, so now I say File New Project, and you'll see here I have business intelligence, and I have analysis services, integration services, and reporting services.
The three core project types are there. Yep.
Now you may recall from the last session you would have seen SQL Server.
Database projects.
Database projects,
Yep.
and that's sort of the cousin, as it were, of these project types. So what I could do, I could import directly from Power Pivot. That model that I just created, I could just bring it directly in to this project into Visual Studio and begin using it.
Okay.
Okay, I'm not going to do that right now.
That's very similar to what Eric and Adam did when they sucked in a schema from a live database. Is that not correct? I mean, the analogy is there.
Yeah.
Okay.
Yeah, but in this case, remember we have the personal, team, and corporate BI stories. Right. This Power Pivot model might have been created by IW.
Okay.
Right, and it may have been something that they had on their desktop and they were working with it and they thought it was really great, and now it's ready to grow up.
So you want to probably use the workbook that they were playing around with to
exactly
bring it in.
as the starting point. Exactly.
Got it.
Or I might work with Excel to kind of prototype with the user, and I get it to a point they can see it. We're testing it out with some pivot tables, and I say, now I finally got it to a good place, and now I import it from Power Pivot directly into SSDT.
Okay, that makes
That's another
sense.
way to go.
Yep.
But the point is that we have this a way of moving back and forth between these various stories.
Great.
I'm not going to do that. I'm going to instead just create an empty tabular project. And you see we have the other project types here as well. And before I actually do the creation, here's the integration project services, and here's reporting. We'll come back and do a reporting services project very briefly. So we'll go ahead and create this. And localhost. It's all beautiful. Now over here, I have an empty business. I have an empty model Okay, but you see it shows up here as a tabular project, and this represents my model file, basically.
Okay.
But up here, you see I have import from data source, and I have a number of other things which we'll look at in a minute. But let's go ahead and get some data in here, and let's bring it in from SQL Server. And again, we'll go here, and we'll bring it in from the same data source, which is the data warehouse source.
Okay.
And here I have to do a little bit more information. It doesn't believe it's me.
Well, we better make sure that it knows that it's you.
And again, I'm going to select, and again, I'm just going to do the same thing I did before.
In Excel, yeah.
In Excel, fact internet sales. And I'm going to select the related tables and finish and bring them in again. And I wanted to show this to show that the same functionality exists.
It's the same set of tools. So if you're a person that lives in Visual Studio, more of the developer type, you'd be completely comfortable working in the Excel workbook mode.
Yeah.
Probably most business analysts aren't going to be working in the Visual Studio mode, but it's really handy that that they had the same interface, the same icons, the same tooling that is consistent across both environments.
Yep, exactly.
Yep.
And you'll see here, I have exactly the same data that I saw when I was in the pivot, Power Pivot. So if I come over here to fact internet sales, I can do the same sort of thing. I can come all the way over here, add this column here, and again, I can say equals, and I want to bring in total product cost, and I did, I think, what was it, freight, right?
Yeah, the calculated column.
Right.
And yeah.
Save that, and it's stored here. I was over in some sales amount right here. And again, I'll say equals, and I'm going to say sum of, and I'm going to bring in, name of the table is fact internet sales. And I'm going to bring in, was it sales amount? There it is right there. Okay.
And there's your, now you didn't, it used to be called a measure. What are we calling that?
In Excel, we call them, calculated fields.
Okay.
But I'm going to change this here so that it's consistent with what I was doing. Whoops, I don't want to do that. Let's start over again. I want to go backspace. I wanted to call this sum of sales.
Okay.
Or maybe total sales or something like that. Boom. That's in there.
All right.
Now, what I don't have here is I don't have a pivot table to go look at, but we'll show you how you solve that problem in a moment. What I wanted to show you first, however, was some of the other things that now light up. So for instance, I can go ahead and, remember I was talking about the scenario where I want to limit what different types of people in the organization
Can see this particular
Exactly.
view. Okay.
So here, what I can do is I can say I want to create a new perspective, and I can say, okay, for this set of users in my organization, I want them to see the promotion and the product and the date, and that's it. And I'm going to call this thing, I'll just leave it as new perspective.
But it
for
might
now.
be like public view 1 or something of
Yeah.
that nature, or team 1. Yep.
Exactly. But then you see here it shows up here, and I could limit what I'm actually looking at. Similarly, I can define roles. So I can define a new role, and I can go in and put filters on what people can actually see.
Okay.
And I can write a filter that would limit it to just the East region. And there's a whole blog post on how to do this, so you kind of get their ID, and you have a little table, and you do the lookup, and so you can do the filter so that it limits it down to the exact set of rows that you're able to see.
Great.
And no, I don't want to save them. Whoops. Cancel. Yes, close it anyway. And the final thing to kind of look at really briefly here is partitions. We talked about that as well, which is that if I want to store 1 year's worth of data on one cluster and another year's worth of data on another cluster, et cetera, et cetera.
So this becomes really important when we're talking about very large data warehouses.
Exactly.
So if you're using something like the Microsoft Parallel Data Warehouse, and you might have terabytes, if not petabytes of information, you would be working with partitions, probably.
Exactly.
Okay.
Exactly. All of this is to illustrate the fact that what you do in SSDT is built so that it can scale up.
Okay.
And it can go out to multiple other users.
So whether you're working with a single kind of SQL Express kind of mode, or all the way up to full-on corporate data warehouse, the tooling is the same.
Exactly. And now what I have here is I have a project. I can check this into source code control, right? So I can do all the sort of team-based things that I normally do, right? I mentioned briefly that if I'm here in SSDT, I want to be able to do things like look at this the way I did in Excel. And here I have, what I've done is I've launched Excel, and now
Your diagram view is what you want to get to.
well, I can't get there from here. My diagram view is back here in SSDT.
Okay.
All I have here now is the kind of view that I would have as a user that's connecting to the model.
Oh, so it's like a preview mode for
It's
what
like a
the user is going to see.
For what the user is going to see.
Okay.
Now I could pre-build this. Now remember I did total sales. So there's total sales.
Right.
And I did, I think, product color or something like that.
Yeah, sales by color, I think. Yeah.
So just
Something
to
along
show that
those
this
lines.
all works, color.
Yep.
Okay, there it is.
Yep.
This is the same pivot table, but now if I come in here and I go to Power Pivot and I say Manage, this is going to be empty because the real model is sitting back in that tabular model that I'm building.
Okay.
This version of Excel doesn't have the model. This is just connecting to the model.
To your existing model. Okay.
Right. So I can use Power Pivot with my model locally, or I can use Power Pivot to connect to a model that the developer creates and pushes out to a different place. And so this is actually just showing the fact that I can now get a lot of that same pivoting functionality, but it's sitting on that server
Right.
far away.
So you've connected Excel directly to your analysis server.
Exactly.
Yes, it's now moved from the realm of personal BI to the realm of corporate BI.
That's right. Now if I go and launch, here we go, SQL Server Management Studio. Local. We will see these are the things we're working with.
Okay.
Okay.
So
So
there's
it's-
your model. Okay.
now I haven't deployed yet, which I'm going to do in a second. These are previous ones I've created. But
Okay.
You'll see that that's actually where it's connected to.
Right.
So I've shown that you can get a preview. I've shown the fact that you have these additional tools. Now what we want to do is we want to deploy. And it's called 34, Project 34.
Okay. Project 34 sounds good.
And we'll go ahead and just do this. And there we go.
Okay.
Close that. Now we'll go back to SSMS
And see if it's
and
deployed.
this right there. There it is.
Oh, then there it is. Project 34. Great. So now we've deployed it up to our SQL Server instance.
Exactly. So now it's live. So what I have shown you so far is I've shown you the fact that I can create an analysis services project and put it into my solution. That's one of the 3 project types that I can create.
Great.
But now that I've created it, I can go ahead and add another project type. So let's add a new project. Let's add a reporting project.
Okay.
And what we'll do here, we'll do the little wizard here, and we'll just call it Report Project 1. And we'll just kind of go through here very quickly. New data source. And what I want to do here is
Find a good database to drive off of.
yeah, the good database we want. No, we don't want this guy. We want server name is local. Where'd it go? Oh, this is the.
Are we on the right?
There we go.
Source,
there we go. There we go. Now we'll try this. And I want 34, which is the one. The one with the GUID after it basically is my workspace database.
Okay.
And that's just for local usage.
Debug and development.
Exactly.
Okay.
So I test this connection. It
Yep.
looks like it's working great. So then I'll say, okay, I want to go ahead and use that. Uh-oh, it's failed.
Let's see. What have we got? Didn't like your credentials? The login failed. Oh yes, it doesn't like your integrated Windows credentials. It looks like. Could you go in as SA or something?
Not to here.
Okay.
But let me just let's do this instead, just to kind of illustrate it. So to save this demo,
Okay.
let's do this again, and let's pull in this guy just to illustrate that I can bring in from
An existing data source.
exactly.
Okay.
Now that we know how to work.
Assuming you have permissions, which I guess we didn't in the last one.
Or exactly. So query builder.
All right. So now you're going to build an actual simple report.
Yeah, except it's not bringing anything up.
Well, we probably have a little bit of a credential problem going on.
Yeah, it is. But here I have both my reporting project and my tabular project in the same solution.
Both in the same solution.
I
Okay.
can check them in, check them out, and
Right.
I can deploy them at the same time.
Okay. And these come, both of those project types get installed within Visual Studio when you do the download off of the SSDT BI website.
That's correct.
Okay, so you have that, and then we didn't mention, but also the SQL Server Integration Services project
right.
type is the third project type.
Yep.
Okay, great.
Very good. So that's what I have for a demo.
We'll go back to slides, and or you have.
Yeah, we
Yep.
have just some basic
wrap-up.
key takeaways
Okay.
here. So the important thing to understand here is that SSDT BI includes analysis services, reporting services, and integration services, those three. They're all available from the web. The major functionality aligns with releases from Office. That's where you should look for big updates. And it works seamlessly with the self-service products such as Power Pivot, Power View, and Power Query.
Great, and we should mention if you're ever looking for these tools in the latest editions or the blog site, just do a web search, a Bing search on SQL Server Data Tools Business Intelligence, and you'll get directed right to the appropriate site on MSDN where you can download the latest commercial release or potentially the latest CTP release like we have going on right now that supports SQL 2014.
Yep.
So all those tools are available just for free, just like in the previous module we saw what Eric and Adam had to show, integrated into Visual Studio, also free for all developers. And so we've seen a recap of what we've shown in this module, the business intelligence tools. Thank you very much, Lance, for the compelling demos and the explanations of the project types supported. In the last module, we saw really the tooling for developers to do schema-based development, declarative development, as well as connected development on top of SQL 2014. And then during the day, we just really want to thank you for being here today. For the previous modules, you also saw about the hybrid cloud and what we have to offer with SQL 2014, integration not only with the development tools we've seen here, but especially integrated with the Azure cloud. So tools like being able to very easily deploy an on-premise database up into an Azure virtual machine or into an Azure SQL database, the backup from SQL from on-premise database up into Azure storage. So really the integrated view of hybrid cloud, being able to bridge the worlds of on-premise data, on-premise databases with the world of really using the cloud to extend your own data center very quickly, easily, and efficiently, and most importantly, cost effectively without having to buy hardware, etc. So there are going to be some evals coming up here shortly. We really, really value your feedback and would like you to take the time to fill out those evals. And again, we just want to thank you for joining us for today's session.